Good morning, sir.
Good morning, sir. Good morning. How are you?
Fine. Sir.
The streaming is available on YouTube or not, sir? Let me check the message.
Good morning, Pawan sir.
Good morning, sir. Good morning.
Banerjee sir will join us soon.
Okay, okay.
I talked to him. He will join within 2-3 minutes.
Okay, okay. Professor A.K. Saxena called me in the morning.
What?
Indira, sir. Professor
Tell
Saxena
me.
from JJ Bilaspur.
हाँ. What
He
he told?
was happy with our वो बहुत खुश थे.
हाँ.
वो भी ऑर्गेनाइज करना चाह रहे
Okay,
हैं.
okay.
पूछ रहे थे कैसे करना. Let us
Okay,
call me
okay,
anytime,
okay.
whatever need, whatever help you want.
Yesterday he messaged me also
अच्छा.
regarding the last presentation. It's good for us.
हाँ हाँ. अच्छा ऐसी बारे नेटवर्किंग हो जाए.
Today we have a good Professor Banerjee. He is very good in machine learning, so he will tell you good lecture. I hope. Maybe within 5 minutes he will join us.
देखना सर मैंने ये YouTube पे दिखा रहा है क्या? एक बार देख लीजिए, वेरीफाई कर दीजिए सर.
Okay, I will check. Wait.
क्वालिटी ठीक है कि ये देख लीजिएगा.
I'm checking. Yeah, it's good. Not issue.
Resolution is good na? I have set HD resolution na?
Everything will be fine.
सर आवाज कट के आ रही है.
Good morning, Pawan sir.
Good morning, ma'am. How are you?
I'm fine. What about
Okay.
you?
I'm good, ma'am. I'm good. Your blessing.
We are blessed. We all are under blessings of Almighty.
Okay. My voice is clear, ma'am?
Yes, your voice is clear. It's very clear.
Thank you, ma'am.
Most welcome.
Good morning, Harshita ma'am.
Good morning, sir.
Good morning to all. How are you, Harshita ma'am?
I am good, sir.
I request all the participants, please ask question at the end of the session. Okay, that will be good for you also. If you have any kind of queries, you can ask without any hesitations. Okay, because the resource person have some expectations to ask the question. Okay, so that participant must ask something. YouTube live, poor resolution. Okay.
कौन सर वॉइस नहीं है आपकी म्यूट कीजिए
Okay. I will call you, Narayan sir. Okay. सर यूट्यूब पे ठीक आ रहा है स्ट्रीमिंग क्योंकि भोसले सर का भी मैसेज आया था स्ट्रीमिंग कैन एनीबडी टेल मी व्हाट इज द स्ट्रीमिंग यूट्यूब इट इज गुड और नॉट रेजोल्यूशन इज गुड और नॉट हर्षिता मैम कैन यू टेल मी अबाउट द यूट्यूब स्ट्रीमिंग
Sir, 1 second, sir. I'll check.
Good, sir. Good, sir.
okay because I have set it in HD quality and I am getting queries that is not good
Sir, what about the today's speaker?
he will join soon Dr. Partha Sarthi Banerjee from BITS Misra
Okay.
Dr. Khan will introduce him. The YouTube quality is good. Okay, thank you, Ruby ma'am. Thank you so much.
It's coming good, sir. YouTube.
Okay, thank you, Archita ma'am.
There is some internet problems. That's why he's joining a little bit late. Means within 5 minutes he will join us.
Okay. He has link or not? I have given the link. Good morning, one and all over there on WebEx. Our resource person will join very soon. Okay, some technical issues. Please have patience. Rajwant Singh Rao sir, how are you? Rao sir, how are you? Good morning, all. Good morning. Good morning, everyone. Please join immediately. Okay. The participants are very few. Okay. There are a lot of queries regarding why we have created the Telegram group link, because most of are addicted to WhatsApp, because there are a lot of participants. We got more than 2,500 participations was there, and WhatsApp can't handle it. So we have created a Telegram group link. Okay. Please join immediately.
Sir, one suggestion from my side.
Okay, sir.
So, अगर आप लेआउट वहाँ पे चेंज करेंगे ना तो पर्टिकुलर टाइम पे जो भी बात कर रहा है वो यूट्यूब पे ज़्यादा क्लियर दिखेगा, क्योंकि आपका लेआउट में मल्टीपल ग्रिड्स एक टाइम दिखती है यूट्यूब में.
Okay. We will switch to, नहीं वो जब सर पढ़ाएंगे ना, अभी तो ये दिख रहा है. जब कोई भी प्रेजेंटेशन लेगा तो सिर्फ प्रेजेंटेशन ही दिखेगा, उसमें और कुछ नहीं दिखेगा.
ओके, ऑलराइट.
ये अभी दिख रहा है एक्चुअली, अभी स्टार्ट नहीं हुआ ना. Neeraj sir, please give me some update. Neeraj sir, are you there? Okay. Good morning to all. Actually, there are some network issue at a resource person side. Okay, he may join at any time. Okay, so please have patience. There are some network issue at resource person side, so that is the issue. That's why he's not joining till then in time. He will join anytime. Okay. Good morning, all. Good morning. Good morning, Monica, madam. Good morning, one and all over there on WebEx. There are some technical issue at resource person side, so we are trying to rectify it. Okay, please have some patience. Good morning, Subhangi madam. Good morning, Umasankar ji.
Excuse me, Pawan sir.
Yeah, ma'am. Please tell me.
Good morning, sir.
Good morning.
Sir, we are not getting anything on YouTube streaming. Only noise
Because
is there.
yeah, because we haven't started. Okay. Please have some patience. Okay.
Okay, I will attend from there.
Okay. No issue.
Thank-
Good morning to all. Good morning to all. It would have to start at 10 o'clock, but due to some technical issues, our resource person could not connect it till late. Okay. So he's going to connect very soon. Okay.
हेलो एम हाँ राठौर सर मैंने फोन से ज्वाइन कर लिया है आई हैव ज्वाइन फ्रॉम द फोन
So now
Hello,
Professor
Pawan sir?
Banerjee has been joined us.
Yes,
Sir, you may proceed.
just a moment. I'm just sharing the things from my phone only, right?
Okay. Let me make you presenter. Okay.
Yes, sir.
Okay. Now you're presenter, sir.
Fine, sir. Just a moment. Let me open it up.
Okay. Good morning to one and all over there on a WhatsApp, on a WebEx. Today with us we have Dr. Partha Sarthi Banerjee as a resource person. Dr. Khan, are you there?
Your voice is not
Yes,
audible.
yes.
You are not audible, Pawan sir.
Am I audible?
Yes, sir. Perfectly audible, sir.
Oh, okay. Dr. Khan, are you there?
Yes,
Ah,
yes,
okay.
yes.
Okay, now I request my colleague Dr. Sohail Ahmed Khan sir to introduce Dr. Partha Sarthi Banerjee. Please, sir.
Good morning to all. This is Dr. Sohail Ahmed Khan, Department of Computer Science, Indira Gandhi National Tribal University, Amarkantak. It is an honor and privilege to welcome all the students of our subject and our subject expert for this today's session, Dr. Partha Sarthi Banerjee. Here's a brief introduction of our subject expert. Dr. Partha Sarthi Banerjee had his BE and MTech degree in Computer Science and Engineering, both from Birla Institute of Technology, Misra, Ranchi. He was also a research fellow for the PhD in Computer Science and Engineering under the prestigious Visvesvaraya PhD Fellowship of Ministry of Electronics and Information Technology, MEITY, Government of India, being implemented by Digital India Corporation at National Institute of Technology, Durgapur, West Bengal. He started his career with Unit Trust of India Technology Services Limited, currently UTI Infrastructure Technology and Service Limited, Government of India, Mumbai. After industry experience, he decided to serve in academics and hence he joined the Department of Computer Science and Engineering at JP University of Engineering and Technology, Madhya Pradesh, a part of the JP Group, India. He is working in the field of natural language processing, unstructured data handling using machine learning. His area of interest include natural language processing, unstructured data handling using NLP and ML. He has designed natural language information interpretation and representation system NLIIRS for MEITY, Government of India. Publications we can access through online. His affiliation with professional bodies include life member of Computer Society of India, life member of the Institution of Engineers India, corporate life member of the Institution of Electronics and Telecommunication Engineers, life member of Indian Science Congress Association. Sir, welcome to this program.
Thank you. Thank you so much, sir. Thank you so much. Share screen.
Thank you, Khan sir.
Thank
Is my screen visible now?
No, sir.
Just a moment. Just a moment. Join. Share content. Select access here. Is it visible now, sir?
No, sir.
Just a moment. Actually, my on my mobile phone it is open now, but I don't know why I am not able to. I'm going to the share content, right? Then I'm going to share screen. I'm sharing the screen. It is saying WebEx would like to access your alert window to make it possible to share your screen in the meetings. I'm doing an
Yes.
okay.
You may try, sir. If you're facing any type of problem, then you may share your slide to us. We will share from here.
Just a moment, just a moment, just a moment, sir.
Sir, right?
Just a moment.
Facing any error? Okay, okay, no issue, sir.
Just a moment, sir. Just a moment. Just a moment. I'll wrap up everything and whatever. Okay, I'm just sending you my slides, sir. Am I audible, sir?
You are audible, sir. Please send to me or mail to me. Okay.
I'm just sending it to you. I'm just mailing it to you under cs_workshop@ingut.ac.in. I'm sending in this. I guess.
Now it is visible, sir.
I guess now. Thank you so much. Thank you so much. And I'm really, really sorry that I took up some time. Beg pardon from you, those who are listening to me. Okay, shall we start with our presentation, sir? Dr. Rathod, sir,
Sure,
shall we
sure.
begin?
Yeah, you will start. You will start,
Okay,
sir.
okay. Thank you so very much. Thank you so very much. Okay, once again, I'm so sorry to all of you, but I'll try my best so that you can get some of the better glimpses of the work done at some of the finest institutions in India. And I'll be sharing some of our work in the area of actual applied machine learning in the area of natural language processing, or in fact, unstructured text to structured data conversions. Okay, so as you can see from the initial introduction slide, I hope the things are a little smaller, but I'll try my best so that, no, you can see it nicely, right? The introduction part, can you see each one of you? Can you see it? Can I get a response from your side?
Yeah,
Yes, sir.
yeah.
Yes, sir.
After zooming,
Okay,
We
fine,
can see.
fine,
after
fine.
zooming, we
Thank you.
can see.
Okay, fine, fine. So let us begin with some of the very important insights into our work of today. Basically, whenever we have talked about structured and unstructured data, I'll be just narrating you some of the stories, and I'll be giving you some of the mathematical deductions of how we actually implement the work that I'll be first explaining it to you. Then I'll be showing you how we have implemented it. Okay, fine. Now, let's begin with something called as structured information and unstructured information. If we talk about that structured and unstructured information, then I'll straight away take you to this slide, that the slide that is in front of you. We generally categorize our data. I'll take you through a smoother transition from structuring of the information to natural language to application of ML in these areas. So our flow will be in a tri-directional manner. So kindly try to put your attention. You'll be able to understand it. So if we talk about the structured information, we'll be basically talking about the data that is having a defined model, or in fact, it is in some kind of format, right? In some kind of format. Now, formatted information or structured information has been in utilization for quite a number of years. Let's say from the beginning of the mid 1990s till 2010, or in fact 12, we had a huge amount of structured information. Now, if we talk about the structured information, then obviously we need to know that what is a semi-structured information. That means little bit structured, little bit unstructured. Now, your question would have been, why are you taking us towards a semi-structured information when we are already having a structured set? Now, let me tell you that if we talk about the practical aspect of a structured format of a data, then we'll be calling it as a DBMS, database management system, right? We are having the structured set of information in the form of tuples, relational tables, schema, and OLTP. All these formats that we see are very, very concise, formatted, and well presented set of information. But over the years, as we have seen that the boom of information has occurred, we found the necessity of having something that is semi-structured or in fact quasi-structured. Now, if we talk about the semi-structured, that means we talk about the textual data files with an apparent pattern, right? We are having certain homogeneous type of file sets that are having a pattern. Now, gradually, even this thing lost its charm over the years. Reason being, when we search a content in Google, we generally get, let's say if I'm asking you that at Amarkantak, what are the places to have the best Bengali sweets out there? Will someone be providing me with a beautiful RDBMS table stating that this is serial number 1, serial number 2 for the first sweet shop, the second sweet shop, or even further? Will I be getting the information in this manner? And then the rate of the sweets for every shop is provided in a beautiful structured format? No. Actually, you'll be getting some of the blogs, or in fact some of the URLs that will be cached, cached on the basis of my index searches that I'll be putting up in my Google search. So that means that the information that I'll be getting for my query, that means the sweet shops at Amarkantak, will be in the form of a textual information or a text heavy information. Text, by the term text heavy information, what I mean is that we are having the text in the form of natural language information, right? In the form of natural language text or information. That means a lot of sentences will be written, a blog about the best sweet shops at Amarkantak or the best sweet shop in Madhya Pradesh. Then some of the information is related to Amarkantak because that is also one of the index valued words in that searches. We'll be getting all those data. Now, to draw your attention, can I even call this kind of information as a highly unstructured information? The answer would be yes, I can call it. Yes, I can call it as an unstructured set of information. That means that the data that has no inherent structure and is usually stored in various different types of file formats. Like you can have the data in the form of PDFs, images, videos. That means I can say that it's a heterogeneous kind of data or the information that I'll be getting. So in today's day world, or in the today's day of information age, the information that we get are around 88% of the information that we are getting according to the Forbes 2021 rating are in the form of unstructured data or unstructured information. Now the question arises is that why is such a big fuss about unstructured data, or so-called, we call it as the data sciences or handling of the natural language information? Why is such a big fuss there? At this point of time, I'd like to take you towards the slide that is right at the middle of your screen. Many of us have got certain amount of idea about the Google Assistant, right? You just click on the mid button of your handheld device, that means your phone, and instantly you get an assistant that is the OK Google format, and you just speak out OK Google, and you get a hell lot of information. That means you just speak it out and you start getting the flow of information in any particular dimension of your choice. Likewise, in case of iOS devices, like you will be getting Apple Siri, or you can even have in the crudest of the forms like Alexa or Google Mini, where you just narrate the name of a song and it starts playing. I'll not straight away go to the application of these unstructured information searches from the Indian perspective. But before that, I would also like to draw your attention towards one of the finest innovations of the century, whose presentation was given by our Mr. Sundar Pichai, the CEO of Google. It was about Google Duplex. Many of you might have heard about this Google Duplex. Google Duplex is a highly innovative AI-based structure that is based on machine learning as well as natural language understanding. That means when your phone starts taking charge of the whole of the device and makes out calls, books assignments, and does all sorts of work that can be done by you with all the finite and the minute nuances. Nuances in the sense that when you give a call for booking up a table in a restaurant, you say, Acha, can we book out a table for 4 people? They'll be saying, no, you cannot. You can have a minimum of 10 people. Then you say, no, I don't have 10 people. I'm just having 4. Can we just minimize the cost? So you are having the cognitive ability to understand the minute information set that has been provided to you in the form of unstructured information, that means in the form of natural language text narrated or orated by an individual. Fine, this is a very complex process which involves the latest techniques of natural language understanding and machine learning processes. But do we have these kind of advancements in our country? That means in India? Yes, we do have it. Yes, we do have it. And in many of the day-to-day applications, you do use it. Like many of you have even seen, while booking your ticket on the Indian Railways, you have seen Ask Disha. Or while going through SBI, you might have also seen Ella, Ask Ella. Now, what are these? These are basically, we call, as many of the commoners, they call it as a chatbot. A chatbot. Is it actually a chatbot which does a kind of conversation between you and the machine, which in fact creates a kind of coherence between the user and the machine? No, actually not. It gives you the information. Like if you go to the IRCTC, you click on Disha, and the moment you'll be typing a train's number, it will be giving you the train's departure, the whole route, the availability of the seats. These are the information that will be given to you. Now, in our prior perspective, before we would have gone for the application of the machine learning processes like hidden Markov model for processing of unstructured information, or in fact linear regression types or naive-based applications, what you would have done, you would have fired an SQL query to extract the information from all the relational tables available with the IRCTC, right? This thing you would have done. But I'm not mocking our systems or our technological advancements, but many of you, those who use this IRCTC portal or SBI or PNBs or various other tech financial tech financial softwares or tech day-to-day usability softwares, you will be finding that they work horribly. They are miserable. If you are typing for an FD, like I want to procure an FD for an amount of 10,000 in Ella, you will be getting a horrendous or a very different sort of information. And at the end, they will be writing down a statement that our bot is still learning. Thanks for the information given. That means right now, the user is not actually the end user. You are basically a trainer for their system. You are giving the informations to them. You are providing them with the set of training for their actual chatbot, which is under the machine learning paradigm, which is going on, still going on. So how to deal with these kind of situations in a complex data handling environment involving natural language understanding, and how we can introduce machine learning in these areas so that we can handle these difficulties. So let us now move towards a little motivation. Many of you might have heard about a gaming platform called as, earlier in until 2010-12, it was very popular. Now, it was basically called as Jeopardy, the game of Jeopardy. And it was first time played by, it's a very popular game back in the United States. What happens in Jeopardy is that they give you some set of prior information. So you can have some cues. That means you can keep some information retained within you. Like you can keep some books, or you can read a hell lot of information. Like if I say that I'll be conducting a Jeopardy. Jeopardy means a Q&A session, a question and answering session. I'll be asking you some questions from medical domain. You have to say who's the first surgeon who has conducted the surgery in India or in Southeast Asia. So you can go through all sorts of medical books for 3 days. Then you come to the Q&A session, and we'll be firing up the questions, and you have to give a reply to that, for which you'll be paid. For the first time in 2011, IBM Watson played the game with human beings, and it won the game comprehensively. Now, what what does this thing proves? This thing proves that while extracting information by using Q&A, why I have introduced the term Q&A? The introduction of the term Q&A is like question and answering. Earlier, what we used to do, we used to write out SQL queries to extract information. Now we are not doing it, even though we do it at the back end for some point of time, but majority of the shift of information extraction for data sciences has gone to Q&A, question and answer. Now, what is this Q&A? Can you train each and every individual to write out a script to extract information, write out a small piece of program or an SQL query to extract information? It's absolutely not acceptable in a country like that of ours. So what we do here is we rely on human cognizance. Okay, fine. You are an individual. You write your question in the way you want to write. Write it in a natural language. Now, here our default natural language is English. Many of you might have asked or might be asking, like, why don't we go for Hindi? Yes, a lot of work is going on for Hindi. A lot of work is going on for Bengali and other regional languages too. But at present, since we are dependent on the European Union as well as with Central American countries, for our business, we try to tend towards development of the software infrastructure on the basis of a default language called as English, right? So now what is happening here? Now we are basically focusing towards English as a language. Now what all things are happening here? Now, let's say in our case, if we talk about that we want to extract an information by firing a Q&A, that means by firing a question and expecting an answer, Q&A, then what will happen? Now we can fire questions like, who founded Virgin Airlines, or who's the founder of Apple computers, right? Now here one more thing needs to be answered. Like, since you're firing a question in natural language, that means from a source you want to extract information, then what should be the source? Here in this case, your source can never be a structured information. If you're getting a structured information, that's well and good. That's well and good. If you're getting the information in the form of a structured table, an RDBMS table, it's fantastic. It's well and good. Why it is well and good? Now, in this case, you will be having a hybrid model. You'll be having a hybrid model. Hybrid model means you are having a structured information and you are putting up a query in natural language to extract the information from that structured information. So what you got to do is you have to convert that query in natural language to a SQL query and then fire it from the table. This is one of the processes, right? Now, if I say that nobody is going to read through the whole of the Wikipedia page on Virgin Airlines and come up with a table, develop a table for me from which I can extract an information, that is somewhat very, very tedious. I cannot expect it, right? So what I can do here is that I can have a PDF file or I can have a text heavy set of information, TEXT text heavy set of information, which will be carrying all the information related to Virgin Airlines or for all the computer companies of the world like Apple, or you can go through the IBM computers, all sorts of informations are there and you can fire a query on that, right? So this is, I'm just giving you the introductory part of it. Now, if you are having this type of, अब मैंने आपको कहाँ से कहाँ shift करवाया ना, you have now shifted from simply writing down an SQL query and getting an information to writing a query in natural language. That means asking a question in natural language and getting a reply in the form of structured information. Your question could have been, what do you mean by getting an answer in the form of structured format? Now, getting an answer in the form of structured format means something. Now, what does it mean? Let's come down to that means. In front of you, you are having a slide that talks about this information. Now, let me tell you what that structured information is. First of all, for all of you, those who are new into the area of data sciences, you might be knowing that when we fire up a query in natural language, we are generally dependent with the WH category words. What, when, these kind of things. What, when, which, WH category words. WH category words are WH category words that gives us, that basically gives us a question forming sentence. A question forming sentence means, what is the color of Ram's shirt? Who found out Apple computers, right? So these are WH category words that makes us form a questionnaire sentence. Questionnaire sentence means a sentence that is of question type. Okay. So it's well and good. Now, if the sentence or the information, the query that is to be fired is in the form of questionnaire, then what is the next thing that I'll be expecting? The next thing that I'll be expecting is an answer from the unstructured information, right? An answer from the unstructured information. Now, we are human beings. We are capable of giving answers with cognitive abilities. Cognitive abilities means if I ask that who's going to win the UP elections this time, many of you will go with a party A, or many of you will go with party B, and some of you will give some of the convincing replies that party A is going to win because they have done these kind of works in Uttar Pradesh, or party B is going to win because they have done some other different kind of works. Now, this is your comprehensive ability that gives you the power to reply to the questions by having pure human cognition. But can you expect it from the system? The answer is a big no. So how to inculcate it? Now let us reduce down the answers in 3 different formats. What are these 3 different formats? Now these 3 different formats are getting the answer in the form of either a factoid reply, or getting a non-factoid reply, or getting an opinionated reply, or sometimes the 4th format that I, or sometimes some of the Stanford machine learning group, they talk about, is the narrative reply. Now, let me explain it to you. What are the 4 different types of information, or the structured information extracted can be? Okay, factoid. What do I mean by factoid? Now, if the answer provided to you is in the form of facts, what do you call, or what do you mean? What do I mean by facts? Facts are like, if I say, from which direction sun rises, your answer would have been east, right? It's from east. Where does the sun sets? It's towards the west. So east or west, if you say only a single word to answer to a query, these type of answerings or information extracted is called as a factoid answering, F-A-C-T-O-I-D, factoid answering. Now, what happens when we go for a non-factoid answering? Remember that as a human, when you ask a question to another individual that, okay, fine, would you like to have paneer today in the lunch? They'll be saying, yeah, I can have paneer, or I'm okay with no paneer also. That means they will not give you the answer in the form of yes or no. They will give you a few sentences, in fact, a few phrases. They'll be saying you, okay, fine, I can have paneer. No, I cannot have paneer. So these are small unstructured set of information, which will be much more like human, right? Much more like human. So these kind of replies are called as the non-factoid replies, right? Non-factoid replies. And the question that corresponds to non-factoid questions, non-factoid answers are called as the non-factoid questions. Generally, they are of complex narrative questions. Just narrative, I previously said that you can even have the narrative segment separately. You can have the narrative segment separately also. But instead of making it separate, you can keep it under the head of non-factoid questions only. Now, next one. So we have now dealt with 3 different types. We have dealt with the factoid. We have dealt with the non-factoid, which can also be clubbed up under the narrative questions. Or you can go on with simply with the non-factoid. And the last one is the opinionated questions. Now, what is opinionated question? Opinionated question is like, it is about decision-making questions. Now, decision-making questions are what? Like, if I say, who's going to win the next election? Should it be Joe Biden, or it can be Donald Trump also? Now, some of you might say that Joe Biden did these kind of works, and he may have a better idea about the United States of America. So he has got a better edge to win in comparison to Donald Trump. Some of you may say, no, Donald Trump is going to win because he's a big businessman. Now, these opinionated based questions are some of the questions that humans reply in a much better manner. Why humans reply? Because they can assess information, right? They can assess information. They are trained. They are machine learned. They are machine learned to understand that how to justify your viewpoint while giving an answer to a query. But can we do it with the machines? Yes, with the present technologies, we can do it with the machines. We can seriously do it with the machines. Now, some of the paradigms that you can see here is like, in case of information extractions, are like IR-based approaches. Some of the finest IR-based, by the way, the term IR means information retrieval-based approaches. One of the approaches are TREC, IBM Watson, Google that you can see. Now, knowledge-based or hybrid approaches can be IBM Watson, Apple Siri, Wolfram Alpha. Wolfram Alpha is another search engine. I hope many of you might be knowing it. It's basically for mathematical extraction of information. Now, you can have True Knowledge EVI and some of the other sources also. Now, while we are talking about the Q&A, we must also have an idea. Two technical terms are also involved. Like what kind of question and what kind of answers are involved in the Q&A for information extraction, for unstructured information processing. Now, the first one is the closed domain approach. The next one is the open domain approach. What do I mean by closed domain approach? Jeopardy is a great game that is a closed domain approach. Disha for IRCTC is a closed domain approach. Ella for SBI is a closed domain approach, whereas Google is a open domain approach. Now, what do I mean by closed domain approach? Where the data or the information is strictly restricted to one particular domain. Like if you want to create an AI-based system or a machine learned system which can reply to the questions, any sort of natural language questions over the FIFA World Cup. That means you can now capture all the information of FIFA World Cup and you can store it in the form of PDF files, and then you can fire a query in the form of natural language question, and you can extract information from them. So this is a closed domain one. That means you can only ask questions related to FIFA, that means football, and nothing else. Now, what about this open domain? Open domain means you are now not restricted to ask the question from a single domain. You can ask question from multiple different domains, anything and everything that is in your head. That means you can type anything on Google and you can put up a search click and you'll be getting the information, some sort of information related to the query that you have put up, right? Now, let us come down to the technicality or technical aspect of it. Let us start up with example number one. Well, I am not intended to give my generic viewpoint towards any individual whose preference for language is very stubborn. What I mean by this sentence is that I'm not saying that if you are knowing English to a greater extent, then only you can go on with the processing of the unstructured information in a much better way. You can go on with your own linguistics arena also. Like if you're good in Hindi, you can go on with your research in that area also. But in our case, by default, we have taken English as our particular area for research. Now, many of us, those who has a very keen interest in knowing the linguistics of English language, they might know that we generally use how many different categories of word that we use in our day-to-day activities or day-to-day oration abilities. We generally use 5 to 7 different varieties like noun, verb, adverb, pronoun, participles, a few, right? But you'd be amazed to know that in actual English language, we are having 36 different types of word categories. Yes, you heard it right. It's 36 different types of word categories that you can find in the English language. Now, 36 different categories means 36 different types of indexes that you need to create for segregating the information in natural language. I'm gradually taking you towards now from unstructured information towards natural language only. Now, natural language is by default the best example of unstructured information. So 36 different types of indexes means 36 different types of parts of speech tags are required, right? Now, the question arises that shall I develop a system for all the 36 tags? Shall I go on with that? No, we should not. What is the reason behind it? Now, if you are developing an algorithm for dealing with all the 36 different POS tags, its growth function for every step will be multiplicative, and hence it will go beyond our control, right? At the present moment, definitely you can have much more better algorithms from your end, which can be much more efficient enough to deal with more than 10 or 12. Generally, most of the work that you're going to find in the natural language processing, you're going to see that people deal with 7, 8, or max 9 tags. That is what I have seen from Stanford Natural Language Processing and Machine Learning Group. you can also visit their site. You can find that they generally deal with 5 to 7 or max 9 tags. So this is what you can basically do. Now we're not going on with the application areas. I'll be talking about the application areas at the end, right? Some of the state of the art works that you can see here is like the Terry Winogard's PhD thesis that is on Sherdlow. It's a procedure on representation of data in computer program way back in 1972. Then you've got a huge amount of work that has taken place, and then finally, at the present moment, you're gonna find some of the finest works in India being Tripti, Doria, Sonal Jain. It was back in the year 2016, and later on, finding a good amount of work that's taken place at our IIT Patna, then in IIT Durgapur, IIT Kharagpur, IIT Bombay. These are the pioneer areas where a very good amount of work in data handling has taken place over the years in the last 4 or 5 years, right? Now, I'll be talking about the first work that you can see. Right? The first work that you can see. We call it as NLIEQA. NLIEQA is Natural Language Information Extraction by Q&A with an SQL interface. In very short, because I am guilty of losing some amount of time, so I'll run a little faster. Like, first device would be not a totally unstructured information based, but a hybrid structure. That means SQL as well as unstructured information. We'll come down to the actual application of ML out here itself. Now, what is it basically? Here, if we talk about the previous works, you do have a parts question, resolve target references, then how to develop the questions based on it, and the projected top answers, and finally returning the exact answer that you can see on your slide at this present moment. In response to these kind of architectures, what we have done out here at NIT Durgapur in coordination with Ministry of Electronics and Information Technology, Government of India, here is the system architecture that you can see. Now, what does this system architecture do? Now, you are having initially an input corpus. That means an unstructured set of information. That unstructured set of information is fired with a query in natural language. And the answer that you'll be getting from here is a factoid answer. Now, what is the technique that has been involved here? Now, the technique that has been involved here is that the unstructured text X is first taken as an input, and X is annotated and then parsed against a pattern for classifying the test. Now, this pattern analysis is where we introduce the machine learning part, and I'll be talking about the mathematical implementation of it today itself. Now, if we talk about the first unstructured text X, then the text processing algorithm developed by us classifies the tags. Next, the text now completely delivers the final representation of the information extracted on which the questions are to be fired. Right. Now, let us see the algorithm to a certain extent. It's a very brief one. Actually, we are having around 3,400 lines of code for performing this whole action, and we are having around 11 algorithms associated with it, which is widely available online under the Mateys website as well as on Springer's headings. Still, like we have created KB1 and KB2, initially we have created KB. What is this KB1? KB1 is knowledge base 1 and knowledge base 2 to store the training as well as the test data. And the questions to store and QES is a queue to store the questions in NLTD form. NLTD means natural language text data, right? Now, if NLTD is available, then we start the process of segmentation, for which we do have a separate algorithm for it. And if the user asks a query, Q&A, and his choice wants to ask a question and his choice is yes, then we go for the Q&A part, and then we provide them with an answer. So it's a very crude and a simple algorithm, presumably, but the extended part of work is pretty complex. So let us see what is the technicality involved. Here, what we have done is we have used a predefined set of NER for our process. As I have said you that this whole process is basically based on a hybrid structure. So what we have done here is that we have used the Stanford's NER for our process. Now, what is this NER does? Now, NER, most of you know what is NER, named entity recognizer. Now, what does this named entity recognizer do in case of text annotation or information annotation is that Now, the whole of the world's information, as per the Stanford's natural language processing group, is basically in the form of three categories. That is what they have said initially, way back in 2014-15. They said that it can be of three categories. What are those three categories? Now, those three categories are organization, location, and person. When the first initial concept of named entity recognizer came up. Now, what is this named entity recognizer? Means not all informations that we do get can be clubbed under the category of 36 word tags that you have seen. That means noun, verb, pronoun, adjective, adverb, all these kind of things. It may have certain classified qualities. What are those classified qualities? Those classified qualities are like, we say that Maruti Omni is a car, right? You will not be calling it as a noun since the word Maruti is being used. You will not be calling it as a noun initially other than the POS tag application. You'll be calling it as a car, right? Now, this is what we know. We objectify the word Maruti because we know it's a car. You'll be calling this Rolls-Royce as a car. You will not be calling it as an organization at that point of time, right? So they said that the initial three things on the basis of which we can segregate the information is organization, location, and person. Then later on, they thought that no, this is not enough. What would happen to the remaining word class sets? What would happen to the remaining word class sets? Now, the remaining word class sets can be grouped up under one head. This was done very casually on part of Stanford, and they clubbed it up under the heading of MISC. MISC means miscellaneous. That means broad three categories remain the same as organization, location, and person, and the remaining all things have come under the category of miscellaneous. Ki baki sabko you just club it up under the one head and keep it there. Then later on they said, no, this thing cannot be done. Let's have some better ideas. So they came up with, now we'll be going on with a 7-class category. What are those 7 classes? Now, organization, location, date, money, person, percent, and time. So here I have put up an example for you. You can also check it out at your end by going through nlp.stanford.edu. They are machine learning extension processes. So you can go there, and this is a freeware that is widely available. You can just put your text there and you can get it annotated on the basis of their NER that has been provided by NLPG of Stanford. So you can see I got a sentence there. Warner works for Microsoft in Texas since 2008 for $200, which is 20% of his previous salary. He wakes up at 6 p.m. in the morning. Now this is a, excuse me, this is a very crude form of language specifically designed so that we can have all the annotated tags out here, right? आप में से कुछ समझ रहे हो कि why did we frame this sentence actually? This sentence is actually to club up all the 7 different categories so that they can be highlighted. So you can very easily see that Microsoft is being tagged as a organization, and Texas being tagged as a location, and 2008 being a date, and all the rest all tags are there in the form of color code that you can see here. This is a machine learning paradigm. We'll be talking about how these things are done. But initially, we have taken the pre-built API for our case. Now, what we actually did is, this is available. Now, when this is available, what they did is, they said that, okay, fine, we are done with the 7 class categories. Now, back here in our country, what we did is, we said, no, even 7 is not enough. So what we did is, we combined this class 7 category and class 3 category. In class 4 category. In class 4 category, we had a special tag called MISC, miscellaneous. What we did is, we involved our training set algorithm to introduce another, the 8th tag, and we called it as others, OTHERS, others. That means anything that Stanford defines as an organization will be organization, but for our Indian perspective, we can have others category also, and that others category is an extendable one. That means it's a machine trainable one. I'll be showing you how it is machine trainable. Now, before we go even further, let me talk about, I don't know how far it is visible. Can you see the table in front of you? Is it visible properly? Can you see it? Can you see the table? Dear audience, can you see it?
We can see it, sir, but size, because you're
Okay,
using
fine.
that is the issue.
Okay. Is it clear? Or shall I just?
It is clear, sir.
Okay, fine. So as we have mentioned in our algorithm that we talked about KB1 and KB2. So our algorithm does the first work. What is this first work? Like let's run in very short format. This part is like you picked up the first sentence with a delimiter. Delimiter is like a full stop. You picked up the first sentence, you segregated it, and you kept it in the form of a tuple in a RDBMS table, right? But what is happening is that we need to have the whole of the information, one sentence in one tuple, which is not possible. This is where you can see that they, in the first tuple, you can see they and rest all fields like person, determiner, activity, time, location, all are null. You can see all are null out here. So this was our KB1, knowledge base one. The next part of the algorithm did another work. What is that work? Now we had the next table called as the KB2. In this KB2, what we did is we kept or we aligned the whole of the information of one sentence in one tuple. Whole of the part of one sentence in one tuple means, let's say if I am talking about Netherlands, Kalam lives in Netherlands. Kalam lived in Netherlands in 1996. That means it is a sentence which is having three important word cases like Kalam, 1996 and Netherlands. These are the three set of information to be kept. So these three information set has been kept in this table in one tuple. That means ID number 1. Likewise, the second sentence is kept in ID number 2, ID number 3, and henceforth. So if it is a 43 ID value, that means 43 sentences are there in our whole paragraph. You can have millions and millions of sentences which can be particularly broken down in the form of annotated tags with a modified NER that has been developed by us in the form of these 11 or 12 columns. Now, some of you could have asked a question, can we have an extension of this column in the real time? Yes, we can have an extension of the column in the real time. That means if you are adding up this others or training or machine training this particular algorithm, you can have an extension of this particular column headers, right? Now, with some of the outputs that you can see here is like if the first text, now the smallest paragraph, what we can have in the smallest paragraph, now one sentence in a paragraph. So for our educational point of view, we are going through only one sentence at a time. Or in fact, in our case, the example that I'll be showing you here, you will be having 4 sentences. So first text that will be processed is Kalam lives in Delhi. So what does our algorithm do? Now it is putting up Kalam lives in and Delhi as an annotated tag, and beside the tag you'll be finding Delhi as a location and rest all are having, it's not a 0, it's an O value, O. The English alphabet O. O means others. Now what it does is the basic 7 entities location classification is what? Now Delhi comes under location, and for classifying the others, that means O category, it will be asking the user to train the system. So we are having a dual facility, whether the user, in first case, the user can also train the system. And in the second case, you can go on with a machine learning paradigm also. Immediately after this, I'll be showing you that also. So let's say the basic 7 entities, on the basis of Stanford's classification, Delhi is under the location head. And for others, what are the fields that are left? Now you can see as what entity do you want to place lives in which category you want to keep. So do you want to keep it in some category, 1 to continue or 0 to skip? We said 0. So the next word is token in. As to what entity do you want to place in which category you want to keep in. Now these are some of the words in the natural language information which doesn't carries any relevance. So under these cases, what you do is we just keep them. I'm so sorry. We just keep them in none of the column headers. So we keep on skipping it. So now the information extracted is, you can see here, entity is location and the entity value is Delhi. Now the second entity is person and the entity value is Kalam. So now, since it is a hybrid structure, you fired a query. The system fires a query, that means alter table QA_NL_IIRS and add location varchar 50 and person varchar 50, and the values added to the location as well as the person is Delhi and Kalam that you can see here. Likewise, we have processed the next sentence. That means Rashmi owns a purple car. Now, Rashmi has been put up under the category of O, owns O, A, O, purple is O, and car is also O. That means the Stanford's NER couldn't classify it. Even their machine learning paradigm couldn't classify it. So what we did here is we did a manual and a machine learned initiative from our part to classify it. What the system did next is the basic 7 categories under which it can be classified is token, Rashmi. As what entity do you want to place Rashmi in? This is what the system asks for. Now, if you skip it, the machine will pre-assign it, or else you have to keep it under one of the headings. So we have said, yes, one, we want to categorize it. Which category you want to categorize it? Now you can categorize it under the heading of C as what entity do you want to place Rashmi in? So that is person. We have said person. So now the next token is owns. As to what entity do you want to place owns in? We have said 0. We don't want to classify owns. Next one is A. We don't want to classify. Next one is purple. Yes, we want to classify it. We said it as color. You can see it at the base of this middle slide. 1, and below that we have written it as color. Now the total extracted information after this step is in front of you. Now you can see the entity is location and the value is Delhi. Entity is person. Value is Kalam. And in the CSV format, you'll be getting what? Now Kalam as well as Rashmi is out here. The next one is entity color. And what is the value for the entity color? Now it is purple. Now the next entity is object. The object is car. Right. Likewise, you do have further. Do you want to go on with further question A? Sorry, this is how you have classified the data. Now you are going for the information extraction. Do you want to go for the Q&A on the given corpus? Y for yes and N for no. Yes, we want to have the question. So the question, please. Now the system asks a question like prompts you to ask a question. You asked a question, where does Kalam lives? This is your question or the user's question, in fact. What it does is it processes the question, and since I have said you it's a hybrid model, it converts the question into an SQL query. This is what the algorithm does. So where does Kalam lives has been converted into select location from QANLIRS, where person equal to Kalam and activity is lives, and then it is fired on my KB2, knowledge base 2 that I have shown you, right? From knowledge base 2, the answer comes as Delhi. Likewise, do you want to ask another question? Yes. Which color of car does Rashmi have? So now this question is again converted into an SQL query. Now select color from QANLIRS, that means the table name, where the object is equal to car and the person is equal to Rashmi, semicolon, and enter. The moment you do it, you'll be getting the answer as purple. So this is how the initial few Q&A could be done on our system. Likewise, further Q&A can also be done. These are some of the more examples that you can see here. Now, while doing so, let us come to the more complex part of it. Let's say, Dr. Rathore, sir, respected sir, how much time do we have?
At 11:30, sir.
At 11:20, at 11:20, just a moment.
We have 15 minutes more.
We have 15 minutes more. Fine, fine. So here we have been talking about set A, set B, and set C. These are the 3 different data sets that we have used. Many of you know that in our exact computation of the output, we use the confusion matrix format for checking the true negative, true positive, false negative, false positive percentages. So these are some of the values, comparative values with the state of the art, right? These are some of the graphs that we have got for the set A, set B, other set of information that we have fed. The 3 paragraphs that you have seen, which has already been pre-annotated or pre-trained, right? So these are some of the things. Now, we'll not go to the conclusion. Rather, we'll come to the conditional aspects of it. Why? Why basically we have taken the help of machine learning, which is a very, very closely associated aspect with natural language processing. Now, immediately after me, there's an esteemed professor from JNU who will be also talking about the application of machine learning or natural language processing. But before that, you can have certain more amount of idea in this area. So if we talk about the application of machine learning methods that we have implemented in this work can be subdivided under the head of supervised, semi-supervised, and unsupervised, even though we have gone for the reinforcement also at some other work that will be following. I don't know whether we'll be having any time or not. So let us see what we have done, what we have basically done, how you have got these beautiful beautiful replies for your queries. Now, the first thing that we have used here is the n-gram model. We have used the n-gram model. Now, n-gram model is the machine learning application of naive-based, right? The naive-based approaches. Best application is the n-gram models. Now, here what happens is, if I want to check from the unstructured information the probability of a sentence, I want to find out the probability of a sentence. So the probability of sentence can be precisely computed by the probability of the sequence of words occurring in it, right? Probability of the sequence of words occurring in it. So if I have to extract an information from an unstructured data set, I need to have the precise probability of each and every word in the whole of the corpus. What we use basically here? Now we use the Markov assumption model that the probability of a word in a sentence depends on the probability of the word occurring just before it, right? Such a model is basically called as the first order Markov model. You can have the second order Markov model. You can have the hidden Markov model also for application, for machine learning applications, right? Now let us see what actually happens in the n-gram model. Now in n-gram model, if you're having a word wn, then its relevance, I'm using the word relevance, not the probability, even though the actual mathematical computation aspect is the probability only. Wn depends on the word preceding it. In fact, all the words preceding it. So Wn is dependent on W of n minus 1. So probability of Wn upon Wn minus 1 is probability of Wn minus 1 Wn upon probability of W of n minus 1, where Wn refers to the word token corresponding to the nth word in the sentence. So let us now see a bit more further. Like a combination of word forms a sentence. However, such a formation is meaningful only when the words are arranged in some order. Now, does the arrangement, that means the semantics of a sentence matters? Yes, it matters, but with the relevance to its machine learning model. Why I'm talking about this? Now, if I say sit, I, car, in the, even though all the words can form a semantically as well as syntactically correct sentence, but at this moment it is not. But still, if you ask for a particular example that can you have a sentence that is semantically as well as syntactically correct, but doesn't have a semantics associated with it, then what can be the answer to this query? The answer to this query is colorless green ideas sleep furiously. It's grammatically, that means syntactically correct statement, but it doesn't carry any semantics associated with it. So one easy way to handle such unacceptable sentences is by assigning probabilities to every string of words. That means how likely those words can appear in the sentence. For that, we do have the machine learning model. That means the probability of a sentence calculation. If we consider, let's say in a sentence, if we consider each word occurring in its correct location as an independent event, then the probability of the sentence can be given by probability of W1, W2, W3 until we reach for Wnth word in that particular sentence. Now, this thing can be calculated in which manner? Since it goes with the first order Markov model of machine learning algorithm, so by using chain rule, what we can have here? Now we can have here, kindly have a look to this expression. Now P of W1, probability of word 1 multiplied by probability of word 1 multiplied by what? Now probability of word 1 divided by EOS, which by default we don't show it in the equations. EOS means end of sentence. That means delimiter. That means a full stop. So we don't have any probability computed for the EOS, right? But in some of the hidden Markov model, computations that will be showing you today itself, usme aapko, you can see it there also. Now, so for the first word, we are having probability of W1. For the second word, what we are having for the case of Markov first order model? Now we can have the word and all its preceding words. So for probability of W2, it will be probability of W2 upon W1. Likewise, for first order Markov model, what should be the probability of word number 3? Now probability of word number 3 is probability of word number 3 upon W1 and W2. That means all the preceding words. Likewise, for the nth word, that means W of n, probability of W of n would be what? Now, probability of W of n upon W of 1, W of 2, W of 3, 4, 5, 6, up to W of n minus 1. This is our chain rule expression for first order Markov model for machine learning algorithm that we will be getting for computation of the calculation of the word probabilities in a sentence for each and every word, so that we can predict which sentence carries more value for information extraction for Q&A. Now there is one more thing to be learned. Now if I am having this expression, then for all the bigram models, you can see that isme pura, you don't have to go through this whole part. I'll be explaining it to you in very short. Now instead of putting up all the values in the denominator, that means if I am going for W2, I have to put W1 for W3, I have to put W1, W2 for W4, I have to put W1, W2, W3. So what is happening here is the probability sequence for the remaining words, that means the n-1th word in corresponding to the wnth word, reduces the numerator's value. So instead of putting up the such long denominators and going on for hefty calculations, we do have a hidden Markov model where we can simply conceal the remaining part of the denominator. So which part of the denominator will be required? Now here in this case, you can see here in this expression, now you can simply go on with the word and its preceding word, not the remaining all preceding words. So P of W2 upon W1, P of W3 upon W2, and P of Wn upon W of n-1. So we haven't computed all the preceding words in the denominators. So we use an EOS tag to mark the beginning and the end of the sentence. A bigram table for a given corpus can be calculated and used as a lookup table for calculating the probability of the sentences. Now let us see a sentence, one sentence from a corpus whose lookup table is in front of you. And from this, what can be deduced? Now, how we can deduce the bigram probability model by using hidden Markov, first order hidden Markov model to get the probability expressions for all the sentences that are available in that particular corpus. Here we are considering one sentence. That means I read a book and you read, and we are using the few words like you book a flight, I read. Right. So these are some of the words that are involved or frequently used word in the corpus. Now, how you are going to read out this particular lookup table? Now, this particular lookup table, we generally call it as the bigram table. So in front of you are having the bigram table. Kindly look at the columns. In the columns, you're going to find EOS. That means the end of sentence. EOS means end of sentence. So end of sentence for a sentence is what? The previous part of the sentence should also be considered as the end of the sentence, and the last part should also be considered as the end of the sentence. The previous part of the sentence's end of sentence part is the full stop for its preceding sentence, and the end of sentence for that particular sentence's ending is the preceding end of sentence for the next sentence. So आपको उतना सोचने की जरूरत नहीं, you just concentrate here. Now you are having end of sentence for the first set of information. After that you are having you, then book, a flight, I read on the column part. Now, what we do here is by using the first order Markov model, that means the machine trainable model, we are getting the probability. Now, how we are getting it? Now, you have to look at the word and its corresponding word sequence in the horizontal part. So let us say that if I need to check the probability for the occurrence of the sentence, you read a book. You can see at the base of the table, there's a column, you read a book. So end of sentence is at the beginning of the sentence also, and the end of sentence is at the end of sentence also. That sentence is what? Now you read a book. How do we calculate you read a book? Now for every word in this sentence, you can have the wnth word and the wn-1th word's probability. So let us see it out here. Now P of U upon EOS. U upon EOS, why? Now at the top of the bigram model table, the first column's first header is EOS, and beside that you can find U. So the first word in the sentence is you read a book. So you with end of sentence, where you gonna see the end of sentence? Now it should be in the horizontal part. In the horizontal part you can see EOS, and below that you can see U. So if you match these two, the intersection of U with EOS is what? Now 0.33, you can see from the lookup table. Second probability is read by you. Read upon probability of read for you is what? Now you have to go to the column where there is read written, and for you it is 0.5. So you have written down 0.05 0.33 and 0.5. 0.33 multiplied by 0.5. Now next word is what? Now next is A upon read. Why we have taken A upon read? Now the word preceding to A is read, word preceding to read is U, word preceding to book is A. That's why we are going in this manner. So word preceding to A is read. So P of A upon read is what? Now go to A part in the column. We have gone to the A part in the column and read part in the column. The intersection is 0.5. So we have written down 0.33, 0.5 and 0.5. And finally we are getting, not finally, the second last part is probability of book upon A. That means you have to go to the A part and then in the book part. So A part and the book part's intersection is again 0.5. So you have written down 0.5. So you are having 0.33 multiplied by 0.5, then 0.5, then 0.5, then 0.5. It is nothing but 0.020625 is what your bigram model probability for this sentence using the machine learning's hidden Markov model. You can get the first order hidden Markov model. You can get this particular value. This is how we have calculated the probability indexes for our data set that we have used for our work. Now the second one, how do we use an exact hidden Markov model process for the computation of the probability? Now, let me tell you that for any machine learning, in case of supervised learning, if you go for the hidden Markov model process, so there's a good example out here. Like if you are having the various word tags, like DET means determiner, ADG adjective, NN proper noun, NNS singular noun. So if you're having these nouns, the arrow shows that the precedence of occurrence of an adjective immediately after determiner is 0.2. The precedence, the likelihood of occurring of NNS immediately after an adjective, singular noun immediately after an adjective is 0.3. The probability of occurrence of a proper noun immediately after a determiner is 0.5. This is what you can see. And the probability of the proper noun holding the values like cat and bet is 0.1. So this is basically a hidden Markov model representation for unstructured text information, textual information. Now let us see how do we mathematically compute it. Now, for a hidden Markov model, it is basically a statistical Markov model. We all of us know it. I mean, you people are also genius in this area of machine learning. It's a statistical Markov model in which the system being modeled is assumed to be within the Markov process and with certain amount of unobserved or hidden states. A regular Markov model, the state is directly visible to the observer, and therefore the state transition probabilities are only the parameters. That's why we use the hidden Markov model for it. Now, during the calculation of the hidden Markov model, we use two tables, or in fact, two probability computations. The first one is the transition probability. The second one is the emission probability. Now let us see how do we mathematically compute for hidden Markov model the transition probabilities and the emission probabilities in case of natural language processing. You might have used it for your data processing models also at your end. But in case of natural language processing, the transition probability is the one-step transition probability is the transition probability of transitioning from one state to the other via only a single step. What is the emission probability? The output probability of an observation from that particular state where you are holding on. And that is calculated via this process. I'll be showing you the process as fast as possible. Let us say we are having an example out here. How do we calculate this hidden Markov model's emission as well as transition probabilities?
Banerjee sir, please conclude as the next resource person is waiting in queue.
Okay, sir. Okay, fine. So there are some of the computations which I have already shared. Fine, sir. I'm just finishing it here only. If any of the audience has got any sort of queries, they can drop me a mail at any point of time. I'll be replying them wholeheartedly. Thank you, sir. Thank you from my side.
Please share your PPT also so that we can.
Sure, sir. I'll be just mailing it to you, sir.
Okay, please. Now, I would like to call Dr. Khan, sir, to propose vote of thanks.
Thank you so much. Thank you so much.
Dr. Khan, are you there? Dr. Khan, are you there?
Yes, yes.
Please propose vote of thanks.
Thanks, Pawan sir. Thanks to our subject expert, Dr. Partha Sarthi Banerjee, for this marvelous lecture based on machine learning based approaches to convert unstructured text into structured languages. It was a very knowledgeable lecture. The content of this lecture was nicely discussed and presented. Here's some learning from this lecture, that we have learned about the differences between structured, unstructured, quasi-structured, and semi-structured languages. A few case studies regarding Google Assistant, Alexa, and Apple series was discussed. And most of the interesting thing of this lecture was that they have discussed the chatbots and its feasibility with respect to the Indian perspective. And it's a very research oriented topic. So we have to do a lot of work on these chatbots. And also experts have discussed NL information extraction using SQL interface, and this algorithm was discussed with various its results and its classifications, its various models like Ngram and Hayden Markov model. So it was a very nice lecture. Thanks, Professor Partha Sarthi Banerjee, sir.
Thank you so much, sir. Thank you so much.
Thank you, Dr. Khan. Thank you, Khan, sir.
Okay, sir. Thank you.
Lobial, sir, are you there? Lobial, sir. Yeah. Good morning, sir. Please unmute yourself. Lobial, sir. Am I audible, sir? But your voice is not coming, sir. Okay, dear participants.
Also, your voice is clear, but we can't hear Dr. Lovial, sir.
Okay. We will see.
Well, sir.
There is some.
Yeah. Let me again. Lobial, sir, please unmute yourself, first of all. Yes. Do you have headphone or earphone, sir? Lobial, sir? Please use it if you have, because we are not able to hear anything from your side. Okay, dear participant, it's our pleasure that Professor Dayakrishnan Lobial from the School of Computer and System Sciences, Jawaharlal Nehru University, has joined us as the resource person for today's session. He's a great scholar, and we are fortunate enough to have Dr. Lobial with us in this workshop. So I would like to request the coordinator of this workshop, Dr. Neeraj Kumar Rathod, sir, to introduce Dr. D.K. Lobial, sir. Dr. Neeraj.
Thank you very much. I'm Dr. Neeraj Kumar Rathod, the coordinator of this workshop from IJN2 Amarkantak. Today we have very eminent faculty of the JNU, Dr. D.K. Lobial, sir. I just want to introduce him. He's the one of the eminent professor from JNU in School of Computers and System Sciences. He has done his BTech in 1998 from Lucknow University, and he has done MTech and PhD in 1996 and 1991 from the GNU respectively. He has a very large, vast experience in the teaching, near about 35 plus years in this field. He is working, and his teaching and research experience in the networking field, machine learning, and the NLP. He is already supervised more than hundreds of scholars in MTech and PhD, and he already taken many projects from the government organization like DST, METI, and AICT, starting from 15 lakhs to the crore. and he already published many papers in different reputed journals. More than we can, if we are going to be specific, 144 papers in the journals, and conferences in 87 paper in the conferences. He already given his expert talk, more than 100 expert talk in different organization and industry. He already acquired many positions in the JNU, like he was a dean of computer science, and he was a director of IQSC. He was a warden and licensing officer. Like this, he got acquired many positions in JNU, and he organized many conferences as well. And he is a member of CSI, ITT, IEEE, ACM, like this. So it's our privileges that today we have a Dr. Professor Robial sir. So I hope you will enjoy his lecture. Thank you very much, sir. Thank you. Over to you, Pawan sir.
Okay, thank you, Dr. Neeraj, for the nice introduction. Lobiel, sir, you can. Okay, your voice is not coming. You just sign out and sign in again, sir. Okay, actually, there is some technical issue. He will join very soon. Okay. Dear participant, please have some patience. Dr. Lobiel is joining again. Please don't leave the session. You will have a very good lecture over. Okay.
No issues, sir. No issues.
Yeah, sir. You are quite audible, sir.
No, fine. So that's why I rejoined.
Okay. Thank you, sir. Thank you. Okay, you can share your screen, sir. On a clicking on share button. कभी कोई दिक्कत हो तो कोई
Still, sir is not audible. Sir, still you are not audible, sir.
Sir, use headphone if you have.
Headphone ही एक है उसका.
Ah, sir, yes, it is coming. It is coming, sir. Yeah. Please speak loudly. It is coming. And share your screen, sir.
Okay, that's fine.
Sometime.
Oh, audible and my screen is visible?
Yeah. Please start slideshow, sir.
Okay. Yes. Visible. The voice is not clear. It is breakable during the lecture.
I'll go to the next room, right? Change my room.
Okay. I think some network issue in his room, so he's changing his room.
Just wait. Let me आ रहा है.
No, sir, your voice is not clear, sir. So it's not audible, sir.
Sir, just insert again your headphone.
Now?
Yes, it is clear now. Okay, please start your lecture, sir. It is clear.
I think it may also be a problem in between. I don't know.
You may turn off your video, sir,
Video.
so that we could have the better voice.
Just 1 minute.
You should stop your video.
No. Okay. Maybe some loose connection. This is the problem.
Loose तो है नहीं, but
yes sir. Whenever you touch
रोज
your
I use
headphone
it
ना,
daily, but I don't know with WebEx नहीं problem. बाकी तो मैं रोज ही इसको यूज करता हूँ.
जी. Just start your lecture, sir.
Just 1 minute. WebEx यूज नहीं करते हैं जनरली ना, तो ये दिक्कत आती है.
Sir.
स्क्रीन नहीं आ रहा, मैं वो देख रहा हूँ ना. आवाज अब तो साफ है ना?
हाँ, साफ है. आप उस माइक को थोड़ा अपने पास रखिएगा तो और अच्छी आवाज आएगी.
ठीक है, माइक मेरे पास ही रहेगा.
हाँ, अब अच्छी आवाज आ रही है सर. आप इसको ऐसे ही रखिएगा थोड़ा पास. जी.
अच्छा, मैं 1 मिनट अपना वीडियो ऑफ करना चाह रहा हूँ. वो
जी. ये स्टॉप वीडियो का ऑप्शन है सर नीचे. आप उसको स्टॉप कर सकते हैं.
ये WebEx फुल नहीं हो रहा ना उसमें.
आपने एक्चुअली इसको डाउन कर दिया है अपने पीपीटी को.
हाँ, वही
मोबाइल से शेयर कर दीजिए. जी.
एक मिनट है, ये रीड व्यू फुल व्यू कहाँ से होगा ये?
आप ना सर स्टॉप करके फिर से शेयर कर दीजिए.
मैं करना तो वही चाह रहा हूँ. 1 मिनट है. अब आ रही?
Please start your lecture, sir, and full size screen, na? Yes. Now it is good, sir.
Okay. Now let me start, right? ऑडियो ठीक है? हेलो?
Everything is good, sir. Please start.
Okay. Anyway, thank you for nice introduction. Sorry for these technical difficulties, and I think there have been a good lecture going on. I'll continue from there, and I don't know how much overlap I will have. But let me be very clear that this lecture will be more of an informative than carrying more details of anything. Therefore, I will divide this lecture into two parts. One is that I'll give little background what natural language processing is in my own way. And then I'll talk about how various techniques of machine learning can be applied, which will largely cover, I will not go as I have written here in the slides. These are points basically which will be covered. That's the idea here.
Sir, your voice is breakable, means sir, it is not audible, sir. Sir, you are not audible, sir.
Voice is not coming, sir. Please reinsert your headphone again.
Hello.
Sir, it is coming now.
ये प्रॉब्लम क्या है? इतनी बार रीइंसर्ट कैसे करेंगे इसको?
अच्छा सर, इसको अब बिना उसके भी अगर हेडफोन के चल जा रहा है तो अब it is coming now. It is coming now.
It is with the headphone.
Yeah.
Coming now?
Yeah, it is good, sir. It is quite clear.
Okay.
तो माइक को अपने मुंह के पास रखेंगे तब थोड़ा आवाज क्लियर आता है. एक्चुअली दूर होता है तो फिर वो ब्रेक हो जाता है.
Hello.
Sir.
It is clear or not?
It is clear, sir. Please start.
तो अभी तो मैं पकड़ा नहीं हूँ. It's mic is all right. What I was talking about is broadly I'll cover a little bit of NLP and then machine learning application to NLP, where basically the deep learning and CNN RNN and are used where they are used in the machine learning. That is what the whole idea is. Still not audible?
Yes, sir.
सुनाई दे रहा है?
Yes, sir.
So let me see what natural language processing is. So to build up half part of the lecture will be on. I'll not go by the traditional way that it is taught, and then I'll go the application of machine learning. So basically, what NLP is the application of you apply computational methods, the models and extract information from the human language. That means how the human language can be modeled and how the human language information can be extracted. That is what, by applying computational methods, that is what NLP is defined. Now, the language may be in the written form or it is a symbolic representation of a spoken or gesture. Or that means I can have a sign language, I can have a speech. It may not have a script. Many of the languages do not have script today, but the language may have a script, that it is a written form, that is called text. It is a spoken form, that is only speech. It may have both. It may be a sign language where I have a gesture or gesture, whatever you call. Now that's what, if I take a written language and then try to apply computational models, that is what is called a text analytics. That is what you have been hearing the word. And if I apply it to the spoken or the speech, then it's called a speech analytics. Then third, if I apply this to a sign language, if you are be hearing something with the dumb and deaf in the news channels, they move their hands and then fingers and then tell about the news. That's kind of a sign language. And then if I deal with sign language, then it can be called a sign language analytics. So these are different kind of analytics which is being done in natural language processing. Now, if you'd be surprised, around 7,000 human languages exist today, currently. That is one. And then you'll be surprised, only top 10% or 10 languages cover the 46% of the world population. That means 10 languages are there which is spoken by 46% of the people around the world. And out of 7,000, and remaining is 56. So that means, and you'll be surprised that the English language is around 1,70,000 words only. So the vocabulary of a language is limited that way. It's at 1,70,000. And that too is, we use only 10,000 words are commonly used in day-to-day. So if you look at the total scenario, and we get confused that, oh, there are so many words and so many things, how can you remember? Languages, English has 1,70,000 and use only 10,000 day-to-day work. So you don't need to have a big vocabulary that way. And if you look at this chart, what you see is that the top 10 language, Chinese is the most spoken because it's a big population. Then second is Spanish because it is spoken in the Latin America. Then English, and if you look at Hindi comes at a fourth, and Arabic fifth, and this last one is Lohanda, that is Punjabi. Western Punjabi is called Lohanda also. So Punjabi is, so if you look at Hindi, Bangla, and Punjabi are three Indian languages which find space in the 10 most spoken languages. Now, and one of the beauty of this natural language is the language we speak is that the shorter words are used most. Of English, is, the, a, all these words are mostly used. So that means the shorter words are used again and again. The advantage of this is, but their meaning is resolved through the context. If they are using repeatedly or being reused again and again, then in the different contexts, they may carry different meanings. So the context is very important. That is what probably the previous lecture also was covering, something about context when we talk of Markov models. So that means the context is very, very important. And the advantage of using shorter words more and more is that it reduces your burden. That means you don't need to recall a large vocabulary. So number of words will be reduced. Also that your brain is free for doing less other. That's advantage. How to resolve this context may be easier for humans. Now,
Loviel sir, your voice is not coming now.
now,
Yes sir, yes sir.
अब मुझे इसको निकालते रहना पड़ेगा और लगाते रहना पड़ेगा. Is what it seems.
इसको सर आउट करके ही रखिए.
आउट करके नहीं चलेगा शायद.
अच्छा, वॉइस कम आ रही है फिर.
समथिंग पता नहीं, बाकी दिन तो ठीक चलता है ये. When I use this Zoom और Microsoft वहाँ सही चलता है.
हाँ नहीं अच्छा वॉइस आ रहा है सर. प्लीज कंटिन्यू सर.
Maybe with the WebEx some setting. Difficulty of natural language processing as to process sarcasm. अगर कोई आपको कोई व्यंग कर रहा है तो it may be more difficult to identify the sarcasm, the irony, the metaphors that they use. That's where the difficulty comes more. I quickly go through this part so that we can spend more time on this. So the ambiguity exists at what sense level? Like say, one word has more than one sense. Any of you are a Hindi speaker. How many of Pawan are the Hindi speakers?
Because we have some faculty from abroad also. So
That because some examples are good examples from Hindi than English.
you can speak, sir. You can speak if.
I'm saying. I can take some examples from Hindi. They are better recognized at times. So, the moment I said the word sense, if those Hindi speakers said, राम ने मोहन को काम पर जोता और मोहन ने बैलों को हल पर जोता. If you look at this word जोतना, काम पर जोतना and खेत पर जोतना have a different meaning altogether, sense. So this is a very good example which comes from Hindi, and similar examples can be from English. Being a native speaker of Hindi, we find better examples in Hindi. That's the issue. So that means the jotna word has different sense in the different contexts. That is what the ambiguity exists. The काम पर जोतना had not same sense as the खेत पर जोतना, बैलों को. Both had altogether different sense of the word jotna. Then the different grammatical structures carry different meanings. I said I saw a man on the hill with the telescope, and the ambiguity comes because of the structure, whether the man was with the telescope or the hill was with the telescope. It's difficult to find out for the computer. As a human, you can find out. That's the sentence structure itself. Because you go from one syntax to another. Overall, what we are saying is we need computational methods which can deal with the ambiguity. That's what the whole processing is. Therefore, if you look at the language models, with two parallels I've drawn, if I take a text, I have to have a, what I do is I have to find out the characteristics of the language which are grouped into different categories. That is what we are saying. That means there's a model where I need to do morphology, how the words are formed. I'll not go in details of that. And then you have a lexical ambiguity. You divide a sentence into tokens. Then you have a syntax grammar of a language. Then you have the semantics. That means how the semantics has to be identified. I'll explain. Then you have a discourse. Then you have pragmatics. That is what you go with the text. If you go with the speech, you have acoustics, you have phonetics, you have phonemes, you have phonemics, and you have projects. These are all aspects which have to be dealt in the language processing. Whether you apply machine learning, you apply some other techniques. Now, if you look at that, morphology is the shape and internal structure of word. If you take a word, goes like that, and dog becomes plural. And lexical means you divide into segmentation text in a meaningful unit. That means if I have a sentence, I can divide a sentence into words which carries the meaning. And then the syntax, as I said, the rules and principles apply to make phrases and sentences. You cannot make a sentence by adding any word in any order. There has to be order. So many text techniques which you apply may not cover that order. That's what the important part. Then the semantics comes where context that provides meaning within a sentence. Given a sentence, can you find the meaning of the sentence from the meaning of the words in the sentence? Right? If I say I eat mango, that means I eat and mango. If I take meaning of every word, I eat and mango, then you find the meaning of the sentence. But if I talk about idiom, probably the idiom will not give the meaning of the sentence will not be the meaning of the idiom, right? That's one. And then you have a discourse. Discourse means it is a group of sentences where the conversations and relationship that exist among the sentences. Because in a discourse, in a paragraph, one sentence is connected with the other sentence, then the next sentence. So it has a coherence in a paragraph. How to cover that? That is called discourse analysis. So you need a different techniques for that. And you have pragmatics. Many times, even if you connect the discourse in a speaker, which is not carried in the sentence, that is outside the sentence. Now, say for example, if I ask you, you go out, and then I say, you go out, please go out. What? Please go out. Go. So that means if I speak louder, my intention is that trying to look you go out, please go out.
Sir, voice issue is there?
Now, hello.
Sir, now it is coming.
बार-बार निकाल के लगाना और क्या करूं? Anyway, जैसे नहीं आएगा तो बता देना, I'll do that again. और क्या करना है?
Okay, it's coming, sir. I don't know what is the issue, but it is the first time, sir, we are facing such issue.
पहली बार फेस कर रहा हूँ.
जी.
मेरे सेटिंग में गड़बड़ हो गया.
कोई इशू नहीं है, सर.
So right, so that means pragmatics means certain information is not part of the sentence, it comes from outside the sentence. It's from the real world context. How to cover that information to get the right sense of a sentence. I'm saying. So it may be intention of a speaker, it may be the information coming from the surrounding. That becomes more challenging as far as NLP is concerned. So this is what the speech part. Today's lecture, I will not cover the speech part, but still, let me quickly go to this slide. Acoustics deals with the representation of the sound. That means signals, how to represent the signals. And then phonetics is converting those signals into the pattern, sound pattern. And then phonology is that pattern which makes a minimum meaningful unit in a language, sound, speech language. Prosodics concerned with the tone and stress and pitch. That means if you look at in a railway station, when an announcement is made through the speech synthesis, it doesn't look like a natural language, right? जैसे हम बोलते हैं ऐसा नहीं लगता because it is generated by artificially, so it doesn't give that human flavor. So processing, if you look at what we do is the work becomes, I do stemming and lemmatization. Stemming is how the different forms of a word are made. Works becomes from work. Work is made from work. Workers is from work. But lemmatization says workers is made from worker. That means category in the derivational. That means from one category to another category is given in the lemmatization. That means what I'm saying is in the first stemming, you say that it simply says that the word is consisting of only alphabets or characters. But lemmatization said no, it's not only characters, but at times they are one form is converted to other form. That noun is becoming verb, verb is becoming noun. That sense is also taken care of in lemmatization. I will not. Sorry. The lexical representation takes you towards dividing into tokens. Like lecture is interesting. If I say previous lecture, not so that means lecture is one token, is another token, interesting is another token. So that has to be done in the lexical representation. One of the key issue in NLP is the stop words. Stop words are those words which does not carry much meaning or almost insignificant in carrying the meaning of a sentence, and but they are quite often, like each, a. If I say, I gave a lecture, I gave lecture, good enough. Grammatically, they not carry, but I gave a lecture or I gave lecture, it carries the meaning what I want to say. So A does not contribute much to the meaning of this sentence. Like the, is, all these are called stop words. If you remove in a sentence all these stop words, then the remaining in a text will be reduced, and therefore the processing can be done faster. So estimate is given that if you look at the Shakespeare's complete work, it consists of 8,84,000 tokens. That's what somebody has done a work. And out of 8,84,000 tokens used in the Shakespeare's work, complete work, there are 100 tokens are repeatedly used, and they cover more than half of the text. That means more than 4,42,000 tokens are consisting of only 100 tokens. Keep that in mind. So that 100 remaining 4 lakh, if I say 50%, there are 100 tokens, and then there are 4,42,000 tokens are different. So it becomes almost half plus 100 tokens. So then your processing time will be reduced. That's what it is. This is what the previous speaker talked about, the N-gram model used for lexical representation. And that you have heard that the sense of the next word will depend on the meaning of the previous word. You can go to the n previous word, that is what n-gram is, 2 previous word, 2 gram, bigram, so on and so forth, by computing the probability. That I will not talk about. Then a document can be represented in terms of a document term matrix. That means if I take my columns as document and the rows as the word coming in all document, then I say that whether some word is coming in document A, B, C, D, then I can fill those cells. That is what I can make a matrix, and that can contain the frequency of a term occurring in a document. This can be one. That is what my bag of word is. Second, each cell can contain the TF-ID, that is called term frequency, and inverse document frequency. That means term frequency means how many times a term is occurring in the document out of the total terms, that is term frequency, and inverse document frequency, that means how many times the inverse of the document term coming in a document out of total inverse of that.
Sir, voice gone again, sir. Please reinsert it again.
Okay,
Sir, yes, sir. Yes, sir.
ठीक है?
जी, sir.
आ रही है?
Sir, आ रही है.
हेलो,
आपकी वॉइस आ रही है सर, अच्छे से आ रही है.
so you can find out the part of speech like noun, adverb, adjective. That is what. So in English, 9 are the most accepted part of speech. I may be in a given sentence, I may be every word, I'll try to find out the part of speech for that. Some languages can have even more than 1,000 part of speech. हम तो 9 ही noun, adjective, adverb, pronoun यही सब जानते हैं article. But some languages, I don't know even those languages, but the literature says can have more than 1,000 POS part of speech. Then I can have a rule-based approach. I can have a statistical approach where you talk of Markov model or N-gram model. They are all statistical approaches. And we can have dependency parsing. Dependency parsing is rather than making a parse tree, what you do, find out links between different words. Dependence, which words depends on which word. If you make a link that way, that is called dependency parsing. Then there is chunking also. Chunking is it's called shallow parsing. And why it is called shallow parsing? Because I'll not see a sentence as consisting of words, but I say sentence consisting of phrases, group of words. If I group words and then make sentence that I said each group of word is a chunk, and then I do my parsing. That is called chunking or shallow parsing. That means rather than doing full parsing, consistent parsing, I am doing only a group-based parsing. This term anybody can go in detail, but then you have semantic relations where you say you have synonyms, antonyms, and hyponymy, and so on and so forth. Also, you have a name entity recognition. Like say, for example, you have to a word have to be identified in a phrase, which may be a person, location, date, time, quantity. I said that Washington is good. Are you talking of Washington DC as a city, or you are talking of Washington, George Washington, the first president of America? How do you identify that Washington? So in a given sentence, the word is referring to a location, to a time, to a person. It's called entity has to be recognized. That is what the semantic representation. And each word is related to other word. That means if I say Ram is cutting fruits with the knife, the knife is an instrument. So the relation between the cutting and the knife is of instrument, where Ram is an agent who is doing the work, the actor, and the object is the what you call vegetable. So these are for relationship. How do I identify it? In a verb, and how the verb is related with the next? That is what calls how to right? Or even you can see that we have semantic labeling. Roles can be subject, object, and so on and so forth. But still semantic relation, like agent, and location, with different semantic roles. I'll quickly finish this. Then in a discourse, you may be measuring the structure and dependence of sentence within a discourse. Then how the sentences in the words in a discourse, different sentences are related. That is co-reference, substitution, ellipsis, conjunction, reiteration, collocation. That means if I say Ram goes to school, he eats lunch there, then he refers to Ram. In a discourse, two sentences that you are trying to say that Ram is, he is as a reference with the Ram. Sometimes we substitute that. What do you eat? I eat mango. Mango is substituted. What is substituted with the mango? Ellipses, certain parts are missing. We remove. Conjunctions. Collocation means, I mean, हिंदी बोलते चाय वाय पी ली आपने, like that. So these are collocations, means two words come together. And reiteration means we repeatedly use a word again and again. And then we refer to the synonyms used. So we say that this is the same word repeated again. And coherence is you try to find out the semantic meaning in a phrase by using the real word knowledge. As I said, where you say pragmatics could be used. Then you have anaphora and cataphora is the how a noun is related to the pronoun in a discourse. That means Noun comes, then pronoun comes. That is called anapura. Pronoun comes first, noun comes after. That is called katapura. So I'll not go into that detail. Important part in before I go to the machine learning approach. Important part here is now in machine language you need to how to represent the words, and this represents is called a word embedding. Embedding that we make a vector space model that every word can be seen as a vector, right? If I make a two-dimensional this and then I say each word is a vector, and or each document, say each document is a vector, because I said each column will be using a term, a word, and how many times this word come is in document. If each column is a document 1, document 2, document 3, if I take a first row, it's a word each. So what is how many times is coming in the first document? It's coming in the second document. It's coming in the third document. So this becomes, if I have n document, the first word I can say, for example, is represented as a vector with n dimensions because there are n documents, right? So it can be represented as a vector space model. But there is a curse of dimensionality. That means many of the dimensions in this can have a zero value. Some of the terms may not come there. And that means I have a very large matrix because I have thousands of words in hundreds of documents. I have a 1000 cross 100 matrix. And large of the space is zero. So that is what the curse of dimensionality is. I have a sparse matrix. So that sparse matrix has to be converted into a dense. That's number one. Which can I remove those which are zero values? That's one. Second, of the word vector model or word embedding is the basic principle is that the words which are coming closer are semantically closer in meaning. They have a semantic proximity.
सर वॉइस नहीं आ रहा है नोबेल सर वॉइस नहीं आ रहा है आप सर आ रहा है
ओके, आप मुझे बताते रहिए जब ऐसा होगा तो।
जी सर
Now text classification refers to given document or given n number of documents, they may be classified into different. That means the document relates to tourism, it relates to health, it relates to a sorry, something else. So given a set of documents, you try to categorize them. How do you do that? That can be done by identifying the text within the document. How do we do that? So that is why we have to have a machine learning approach for classification of documents, but that will also require some of the NLP techniques. So this is one. So in addition to this text classification is the core of most of the NLP applications, which we talk about. It includes information retrieval, spam detection, sentiment analysis. Right? Whether some आजकल इतना ट्विटर आता है and you try to say whether this is a positive tweet or negative tweet or neutral tweet. They are politically very highly polarized. So how do I identify the sentiments of a tweet? So given the text, I'll analyze that. I may apply certain machine learning techniques for that. Normal techniques of classification, you apply SBM, you apply something else. I will not go in those techniques because we have studied maybe a lot of techniques of machine learning. So I just spam detection. Email. There's something in this. How do you do that? Either you have a clustering technique or you have a classification. So is your information retrieval. When query is given, you have to retrieve the answer of the query. How do you do that? Unless you try to get the meaning of a query, you may not be able to find out the relevant document. Two things. You have to find out the relevant document, and from the relevant document, you have to find out relevant information. Two steps. How do I do classification that whether document is relevant or not? One level of classification where machine learning can be applied. Second level of classification is even if I find out a relevant document is relevant for you, what is not relevant. Not that everything within a relevant document is relevant for you. So again, you apply certain classification to find out which text within a document is relevant for you and which text is not relevant for you. So therefore, what happens is in a text classification problem, we can apply a supervised machine learning approach. We do. So you need a document representation first, either vector space model. Then you need to apply feature selection that sorry, select certain important features from that document. Apply machine learning classifier. Whether you apply SBM, a linear regression, a logistic regression, and anything method you apply. Also, you need to have some kind of a evaluation of a classifier. How to evaluate the performance of a classifier, that is equally important. NLP, in language processing, when you are doing text classification, you can apply these machine learning techniques, but you also must have a knowledge of the natural language processing. That's what is important. So what do you do? So you have a given a set of documents, which I call label documents. And documents which are labeled documents. The first step is to construct a representation. How do you do that? The common is called a bag of word, which I said the vector is a bag of word. That means every document has a bag of word. Right? There are words. Then you say that whether word 1 occurs in all, which document occurs in which document. That is what a vector is. Then word 2 in which, word 3 in which. But some of the word may not be occurring there. That is not part of your vocabulary. That will also happen. Then we call them out of vocabulary word. Then whether that has to be added or not, and how to deal with the words which are not in my vocabulary. That is another issue. But the n-gram frequency also is one of the methods of bag of words, or TF-IDF I talked about another. So what is your set of a labeled document is called X1, Y1, X2, Y2, Xn, Yn. What is your X1? X1 is a vector representing a word, and Y1 is its output. That's what we call Y1 is a label. So you have a label set of documents, vector, right? So that means what you are defining is that set can be defined in terms of vectors along with their output value labels. That's how you can represent your documents if you are applying a machine learning. Thank you. So this itself is a big task. So what you need is you need to convert a given document in a vector space model. So that means you need to have tools available with you if you are doing Python, which can convert a given document into a set of vectors. That's the first task in doing NLP, applying machine learning, using machine learning. First task is convert your text into vector space. Done that.
सर वॉइस चला गया मुझसे।
आया?
हाँ सर आ रहा है।
आप भी स्लो है।
जी जी।
अब आ गया?
हाँ हाँ आ गया, लेकिन थोड़ा कम आवाज आ रहा है। आ रहा है।
अब
जी जी ठीक है सर, ठीक है।
So, what do you use? Then you have an annotated means where the labels are not given. Then you predict the labels. That's what the classification is. And the most common or popular algorithms which are applied for classification is K-nearest-neighbor, tree, array-based, logistic regression. These 5 are the most common machine learning algorithms used for text classification. That's why I said this lecture will be more of an informative than really going deep into any technique. So this is what people have been using in text classification using machine learning. Now, but that is not sufficient. A useful technique which people are applying is convolution neural network, CNN. Why CNN is useful for text classification is captures the temporal and hierarchical features in a variable length. Keep that in mind. A sentence in a given text are of variable length. Every sentence will not have a same length. That is very common. But when you make a vector space model, in a vector space model representation, you are making it every sentence is of equal length. That is what you assume. Because where the words are not contained, you assume value 0. But that is where the problem occurs with the previous algorithms which talked about 5 decision tree, Bayes, naive Bayes, because that we are using only fixed length words and it may take more time. Advantage with the CNN is the convolutional neural network is that it is able to take variable length. Second is the language structures are hierarchical. If you look, R's tree is a hierarchical tree. So therefore, the features will also have a hierarchical relation. Time relationship is equally important. Whether it happened today, it happened past, whether it is past tense, present tense. So these aspects can be captured very well by the CNN. That is one. And word or character embedding is generally the first layer in these frameworks. Now, one of the important part is generally we use word embedding or word space we are making is for words. Can I make a vector space for characters? Right? Given a word, I take words in the columns and characters in the row, 26 characters, what is Maya, then you fill up these cells. Huge matrix. And so do a character embedding in a sense, 26 characters, and if you take the entire sentence, then you can say that characters are part of this sentence. That is called character embedding. You can make a vector space model for a given sentence. And this can be given as an input to the CNN. Right? And then CNN can capture that, number one. And further, deep CNNs are considered to be more because they captures the complex features of all natural language processing. That is where people are working on. So I said convolutional network, neural network, and deep CNNs are important as far as text classification is concerned. That is what the current research is going on. Then also now RNN, recurrent neural networks, are considered to be the most useful for natural language processing than even CNN. And you can have a deep RNN as well. Why? Because recurrent neural networks are able to capture the sequences. Because because you might have heard the lectures for CNN, RNN in the machine workshop earlier. I did not make my slides on those. I'll use that, hoping. That means what in a recurrent neural network happens in every time step, memory of previous sequence is contained. That means the time step n is depending on time step n minus 1, n minus 2. That means in a word, if I give a sentence, first word is given input to the second, right? And third, the history is being used by the RNN, which is important because in a sentence, the context is important. If you have heard this HMM where you said the n-gram model, the probability of this word n depends on n minus 1, n minus 2. That is where the RNN are very useful. Extend n-gram models, right? So that is why I said that the sequence encodes the word embedding at each time step. That's what RNN considered to be more important for NLP applications. Once the entire sequence is encoded in a sentence, the last hidden state is used to predict the class. That's advantage of RNN. That means if the nth word is used and contains the history of n minus 1, that means the context of the entire sequence is there. So you predict the class, your classification will be better. That's what it is. Which class this sentence belong to if you are doing classification. And another important is RNN is trained using BPTT, that is back propagation through time. And back propagation is very, very important in neural network. The RNN, that is an important. I'm only throwing the term here. I cannot go in detail for the time limit, and which you can go. I'll give you a book. And then advantage is the weights are learned.
Sir, voice.
आगे
Sir, आगे.
Learn sequentially where the words. That means the weight of the first word is learned, weight of the second word, the weight of the third word. Third is we learn the weight. That's very important. Important application of NLP where machine learning is used highly. Generally, sentiment analysis, what we have been doing is have been applying fuzzy logic and maybe other logics, where a sentiment can be a favorable, positive, unfavorable, negative, and neutral. Or you may be still fuzzyfy it by saying that degree of favorableness, इतना अच्छा है, बहुत अच्छा है, very good, good, quite good, extremely good. Important is you find out the subjectivity and objectivity of the sentiment. It's given a sentence. Can I find out the sentiment of this sentence is objective, subjective? Like say, for example, you can have an opinion about something or you can have an emotion about something. If you look at your opinion, opinions are always subjective, right? And objectivity, the emotion has objectivity. You may be happy, you may be sad, objective. Now, in a sentence, whether it is an opinion sentiment or it is an emotional sentiment, you can classify into category. Again, you can use classification techniques, and based on that, and you can say whether this is subjective and objective. A piece of text given to you, you can find out the subjectivity and objective. That means if I have more than one sentence, I'll put the score of every sentence and finally add up the score. Which has more score can be classified in some, and I have a threshold. This is useful in detecting fake news. And that is where the machine learning techniques are applied. Find the fake news in case of a Facebook and social media. Therefore, the classification is important. And three things I said: balance, That means what is positive, negative. Arousal, intensity, what is the degree? Then your dominance. This one emotion may dominate other emotion. And then also in the sentiment analysis, CNN framework people have tried and found out that it is very effective in class. Right? Because you can consider more and more features and complex features. That is where the CNN will be useful. And also RNN also is very useful because it captures the sequences and the more complexity in the structure of a sentence. Even it can capture the negative. Even a positive sentence is said in terms of a negative sense. In a sarcasm, a sentence is positive, but it gives a negative meaning. Right? I can it may not be a compliment all the time. I may be making a comment. So though it seems a good sentence, but it carries a negative meaning. I'm not appreciating whether I'm trying to make a comment. Right? So this is a sarcasm. How to identify that? The RNN is found to be useful in that. Right? The reason is it may be capturing a lot of context of a previous sentence and is trying to find out. But in a sequence, if you find the past context as well as the future context, RNN can identify the past as well as the future context of a sentence and give you the total meaning. And therefore, and they also have dual LSTM. Now, short-term memory-based neural network is found to be very good for finding sentiment matching. Dual means though LSTM use करेंगे, that is dual. I'm just throwing these ideas, but if anybody is interested, can take on. I'll give a very good reference book. Entailment is another aspect of natural language. That means, can I find a logical conclusion from a given truth? Then I can find some logical conclusion. That means, when I say A is married to B, it logically concludes to B is also married to A. Right? I say A is husband of B implies that B is wife of A. So when I given a natural language sentences, when I infer a leading truth from the given truth, that's called an entailment. And there have been people have done work and they have used parse trees to find out that, and then use SVM and logistic regression analysis for that. Probably people have not yet tried CNN and other things. That's what entailment remains an open research topic. And it needs to work on based neural network for entailment. Area people have not worked much on that.
Sir, some voice issue there again. Nobel sir, is there is some voice issue again?
Again, आ गया ठीक हो गया?
जी जी जी
जाता है और ठीक हो जाता है.
जी 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 सर.
Okay.
Sir, please try to complete it soon, sir, because we are running time. We are running late a little bit.
Okay. Just मैं complete ही करता हूँ.
Okay, sir.
ठीक है ना? So,
sir, please.
Yeah, I'll do. Last minute.
Yeah.
So that is one area, and okay, I'll see. And the techniques used is called LSA, and this, but important part is I'll go these normal techniques. I'll see. How clear?
Clear, sir, clear.
One of the important machine learning approach used is CNN for topic modeling, because coherent, I talked about when I talked of discourse, I talk of coherent. That means how the referencing and ellipses between two sentences can be taken care of. That is called your discourse. CNN is considered very, very important as far as coherent and effective interpretation of a topic modeling. That is what I have not given the references. A lot of work has been done. And the context of the document is captured well by the CNN. That's also important. And to each, we have topic vectors. That means what I say is different references and different topics. Words, I make matrix of that. I have a matrix of a document and words, and I merge them together. That is called a combined document vector and topic vector. If I use them together, it gives a very effective, useful. Then I use CNN as the input. I give both. Then it gives a very good topic representation, and then I can apply CNN here to find out the good results of a topic model. I'll quickly skip this. The important is machine translation, and where the recurrent RNN are very highly used. And one of the important part of this is to use language from a sentence from one language and convert it to another one. The important is the encoder and decoder based analysis is very, very important. But it's developed by Google translation system based on the encoder decoder techniques, which I call transformer at times, where your RNN are used for translation. So if you are using translation with Indian language or other languages, use RNN for translation between two languages. Skip this slide quickly. So machine translation is a very, very good example. And BLUE, bilingual evaluation under study, is a very good matrix developed for evaluation of these systems. Question answering system, CNN can be used. If automatic text summarization based and based, and quickly I'm trying to. And the library is used for this work is NLTK is a very, very important tool, which is by Stanford library, which is open source, are used for text analytics. Then you have Spark Sci is an open NLP library for post tagging NER. GenSim library for open backspace model convert, so you can use GenSim library. And all this can be combined with the Python. You have a Keras for learning APIs for deep learning. Then you have TensorFlow for machine learning. You can have scikit learn, which gives you a lot of algorithm, machine learning algorithm, and Pandas library for data service. If you combine all these tools, then you can develop very good machine learning based approach systems for NLP using Python. And of course, matplot everybody knows. And with this, I'll conclude. I'll give these slides, not a problem. So neural machine translation is one of the most significant application of NLP tool. So that's the hot area. A lot of work still needs to be done for Indian language. And huge efforts are still required for generation of corpora for Indian language. Until unless you have a good corpus, we cannot develop empty system and you cannot apply machine learning. And still we don't have a digital corpora for many of the Indian language. And reinforcement learning is another area can be useful for NLP applications. The reason is it temporal dependency and non-differential optimization. The gradient fails, therefore the reinforcement learning works well. It can be used for text summarization. And you have heard something like video storytelling. Means if given a video, can I identify the caption of that? That is also an NLP area. And then, yes, this is the book which you can follow. The Deep Learning for NLP and Speech Recognition by Uday Kamath, Springer 2019. Latest book is a very good reference if you really want to learn few things about machine learning for NLP. That's the idea, is to give an information, not to go in detail of anything. With this, I'll thank you. Thank you very much.
Okay, thank you so much, sir. Dear participant, do you have any query you can ask to sir? Participant, do you have any kind of queries? Okay, you can put me. Okay, so there is a query. Which NLP model is the most accurate? Lovial, sir, there is a query. Which?
Am I audible?
Yeah, quite audible. Your voice is not coming again, sir.
Agi?
Yes, sir. आ गई.
If you are doing machine translation, deep neural net or recurrent neural networks are very good for machine translation application. Right?
Okay. Did any more queries, participant? Okay. So it was a very good and nice lecture, sir. It is my privilege and honor to propose a vote of thanks to you, sir. On the behalf of the organizing committee, Department of Computer Science, IGNT Amarkantak, I propose a vote of thanks to Dr. D.K. Lopial from the Department of Computer Science, Jawaharlal Nehru University. Sir has delivered a very fruitful and very great lecture on machine learning applications for the NLP. Sir have discussed natural language processing, but how it is basically being used, how machine learning use NLP. Sir have discussed semantic discourses, pragmatics, text classifications, and what are the machine learning approaches behind them. Sir have discussed about the text classification using RNN and RNN using BPTT also. Sir have discussed about entailment, topic modeling, and how it is being used by CNN, and machine translation, what is fluency or faithfulness, etc. And sir have also discussed about bilingual evaluation, understood as BLEU. And sir have talked different software used for the library, for example, NLTK, SPACY, Genesis library, and so on. Sir, it was a very great lecture, and although we know that there was some little bit voice issues, but we are able to understand whatever you are telling to our participants. Sir, on the behalf of all the participants who are attending on WebEx, I welcome you. I thank you, you sir, for this great session, sir. It was our pleasure that you have joined our workshop, sir. Thank you so much. Thank you, sir. And please share your PPT so that we can share with our participants, sir. And I have mailed you, sir, one honorarium receipt, sir. Please sign it and send to me, sir. Please, sir. Thank you so much, sir. Have a nice day ahead, sir. Thank you. Thank you, sir. Thank you. Participants, we will meet at 1:30 sharp. And I have signed the attendance link already. And the time was, attendance for the time was 12:30 last. But now I am sending again, but time is over. We will meet at 1:30 sharp, okay? We will meet at 1:30. So have a good lunch, okay?
पवन जी नमस्कार।
नमस्कार सर, नमस्कार। हाउ आर यू सर?
हेलो।
हाँ सर, हाउ आर यू?
सर आपकी आवाज नहीं आ रही है।
ओके, लेट
Now, sir, it is
मेरे पास तो नहीं आ रही है सर। हेलो।
हाँ सर, नाउ इट इज कमिंग। राजीव सर, इट इज कमिंग।
एक मिनट सर, एक मिनट एक मिनट।
is it coming now?
अब आ रही है, अब आ रही है। हाँ
And now, sir?
हाँ हाँ बिल्कुल आ रही है, अब आ रही है।
ओके
थैंक यू।
ओके, थैंक यू सर। ओके, वी विल स्टार्ट एट 1:30 सर, है ना? लेट मी
हाँ 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 बिल्कुल ठीक है, मैंने कहा पहले एक बार टेस्ट कर लें।
जी जी प्लीज। ओके, आप अपना एक बार स्लाइड ऑन करके देख लीजिए सर। इट इज
हाँ हाँ वही वही कर रहा हूँ, वही कर रहा हूँ। वीडियो भी मिरर कर रहा था, वो उल्टा आ रहा था।
जी जी जी।
वीडियो भी मिरर कर दिया। विजिबल है सर?
हाँ, गुड गुड।
है ना?
यस सर। So how is the weather, sir?
वेदर ठीक है आज। आज ठीक हुआ है, मतलब
जी
कल
जी।
तक तो शीतलहरी चल रही थी।
अच्छा अच्छा।
हाँ
यहाँ पे
आज
तो कल, यहाँ पे काफी ठंड हो रहा है अमरकंटक में। कल तो यहाँ पे एक बर्फ भी थोड़ा जम गया था।
सर देखिए, मैं हूँ मध्य प्रदेश का आदमी, ठीक है ना?
अच्छा ठीक।
हाँ
जी,
तो
आप तो ज्यादा अच्छी तरीके से जानते हैं।
अमरकंटक और पचमढ़ी,
जी
अमरकंटक और पचमढ़ी ये दो ही चीजें सुनते थे बस, जा
जी जी
कभी नहीं पाए।
जी जी
यही दो जगह जो है ठंड होती है मध्य प्रदेश में।
जी
बाकी
सर।
जबलपुर वगैरह तो सब
हाँ,
ऐसा है
जबलपुर
कि
में तो, जबलपुर में तो काफी नॉर्मल है
पत्थर
वो
भी जो
तो।
है वो,
जी।
नहीं बहुत गर्मी होती है, गर्मी बहुत ज्यादा गर्मी। पूरा
सर
हम तो
जी जी
सतपुड़ा बेल्ट वाले हैं, सतपुड़ा के घने जंगल।
जी सर। एक बार जरा मैं टेलीग्राम पे सर मैसेज ड्रॉप कर देता हूँ ताकि पार्टिसिपेंट जुड़ जाएं।
जी जी जी, ये अवश्य। तो पैन इंडिया से हैं लोग इसमें जुड़े हुए?
सर पैन इंडिया से हैं, इवन कुछ लोग तो बाहर से भी हैं, आउट ऑफ इंडिया से भी हैं।
अच्छा अच्छा, ये ठीक है। हमारा फील्ड ऐसा है कि कहीं भी फिट हो जाता है साइबर सिक्योरिटी आजकल।
सर ये तो हर जगह है, कोई भी
हम्म,
सब्जेक्ट हो सब में
और
साइबर
जरूरत है।
सिक्योरिटी, क्योंकि जी, क्योंकि सब लोग कंप्यूटर यूज कर रहे हैं, सब लोग नेट यूज कर रहे हैं तो। रूबी मैम, आर यू देयर? रूबी मैम, आर यू देयर?
Yes, sir.
Okay, we will wait for 2 minutes more so that
Okay.
okay.
Good afternoon, Rajiv, sir.
नमस्कार नमस्कार रवि मैम। So today is the last day? Tomorrow?
No,
Tomorrow
no,
is the last day.
tomorrow is the last day, sir.
So did you have lectures yesterday?
Yes. We have, sir. We have 4 lectures yesterday. Daily we have 4 lectures, and valedictory will also there at 4 to 5.
गुड आफ्टरनून सर।
गुड आफ्टरनून अभिषेक जी, कैसे हैं?
नमस्कार सर, बस बढ़िया सर।
नमस्कार।
और आप कैसे हैं?
बस बढ़िया बढ़िया
बढ़िया। चलिए सर, आप कभी आपको यहाँ बुलाएंगे यूनिवर्सिटी।
एकदम सर। मेरा तो
हाँ,
मैंने जैसे अभी बताया पवन जी को कि भाई हम तो मध्य प्रदेश के वासी हैं।
बिल्कुल सर, बिल्कुल। बढ़िया सर।
यानी आप लोग भी यहाँ आए तो जरूर आए, है ना?
हाँ श्योर सर, मैं तो आगरा से ही हूँ। बिल्कुल।
हाँ।
Bansal sir, it is streaming on YouTube ना? Bansal sir?
YouTube सर चेक नहीं किया मैंने, चल रहा होगा सर?
हाँ चल रहा है, I think. Okay, it is over there. Let me record the meeting so that okay, meeting is recorded. Okay, Ruby ma'am.
Yes, sir.
Okay.
Yes.
Good afternoon to all the participants of this workshop. It is our pleasure that today's session resource person we have with us Dr. Rajiv Ranjan Singh sir. So I would like to request Ruby ma'am to introduce Dr. Rajiv Ranjan Singh sir. Ruby ma'am, over to you.
Good afternoon, everyone. I feel so happy to be part of one week international workshop on machine learning and its applications, which has been organized by Indira Gandhi National Tribal University, MP. And I take it as a proud privilege to introduce the resource person, Rajiv Ranjan Singh, who is an academic and researcher in the area of cyber and information security with almost 2 decades of experience. His research interests include formal verification, protocol analysis, e-governance, cyber safety education, and awareness. Apart from teaching in University of Delhi and its constituent colleges, he has also been associated with reputed institutes and universities like University of Birmingham, UK, Birmingham City University, UK, JNU, IBS, NAFM, IGNU, and in various capacities such as tutor, visiting faculty, course content writer, and examiner. Since 2009, he is serving as an assistant professor with Department of Computer Science, Shamlal College, University of Delhi. He has submitted his thesis as a research scholar in cybersecurity with School of Computer Science, University of Birmingham, UK. The various research work conducted by him comprises security protocol verification, analyzing various attacks on security protocols, using automatic verification tools such as Tamarind Prover, SAPIT, and use of theorem prover such as COQ, building utilities with Python. He had his publications with Springer, International Journal of Secure Software Engineering, and contributed many units in IGNU study materials such as PG Diploma in Information and Security, Operating Systems for BCA students. It is an honor to be talking about this person who has made a mark in the field of computer science as being awarded fully funded studentship for 3 years by School of Computer Science, University of Birmingham to pursue full-time PhD in computer security from University of Birmingham in 2016. Also as a winner of 2016 Research Skills Award. He has been selected under faculty training program in 2012 by University of Delhi to pursue fully funded MSc in Computer Security from University of Birmingham in 2012 to 2013. So I would request Rajiv Ranjan Singh to present his valuable insights entitled Adversarial Attacks on ML Algorithms.
First of all, thank you, Ruby ma'am, for such a generous introduction. I don't know whether I deserve such an accolade or not. But at the outset, let me put forward my sincere thanks to Dr. Abhishek, Dr. Pawan sir, and everyone from computer science at Indira Gandhi University. So it is indeed a pleasure, and I like to take my work out. So when we started talking about this program with Dr. Abhishek, then there is this recent phenomena on attacks on machine learning, adversarial attacks. So I'll try to give a solid pitch to this idea since the time is only 1 hour. So I will not go into the technical details, but I'll touch on the surface. And the idea is that I'm trying to get you aware, make you aware about this new area. I would be really happy if someone can stop me in between and ask the question. I don't mind. Or you can, if you feel like, you can postpone your questions for the end. So Pawan sir, is it visible, sir?
Yeah, it is visible, sir. Please go ahead.
Okay. So good afternoon, everyone, and one and all, and I hope you all are doing well. So this talk is about adversarial attacks on machine learning algorithms. So I think I should skip this since Ruby ma'am has said more than I deserve. So let's dive direct into the topic. So the first thing, when we talk about any attacks, is this message for me? The YouTube link? I guess not. Okay. So whenever there is an attack, we have to understand who is the attacker and what are the powers of an attacker. So in cyber security, there are certain basic principles for an attacker. We believe that the network belongs to the attacker. So when you start sending the data, and when someone receives the data, right, in between, when the data is traveling, at that time it belongs to the attacker. At that time, the network belongs to the attacker. So the attacker can mount active attacks or passive attacks. In active attacks, attackers can stop, inject, or replay anything. Or in passive attacks, they will just monitor the network without making any changes. For example, if you are sending someone from your home with a packet to your neighbor, you only know that someone went out of your home, and then what you will receive the phone call from the neighbor, okay, I received the packet. But you don't know what happened to the packet in between. So someone might put something, someone might take out something from that packet in between, or a third person may just monitor this person at this time comes out of this house and goes into this house. All these informations are very valuable, as you will know. And in terms of security, there is a zeroth principle, which is like the security of a chain is as strong as its weakest link. So in our whole security system, even if there is one vulnerability that might allow the attacker to get into your system, we will talk about that. This is a very famous movie, Catch Me If You Can. If you haven't watched it, I strongly recommend that you see it. It is about an FBI consultant who was earlier a criminal, and he is now a consultant to FBI. He gives his advice on how to catch criminals and all. And he says this: every single breach occurs because of two reasons. That the company did something they were not supposed to do, or someone in the company did not do what they're supposed to do. बहुत simple words में, in very simple words, that we should only be doing what we are supposed to do, and we should always do everything what we are supposed to do. So the attacker tries to do something, tries to fool you into doing something that you are not supposed to do. And that is where the attack occurs. There have been many examples of cyber attacks using machine learning, such as CAPTCHA bypass. So in CAPTCHA, you know that you have to use your human eyes and enter something. But using machine learning, that has been broken. Password has been broken using brute force and machine learning. There are malware filters, and machine learning has been used to evade those malware filters and pass on the malware deep into the network. And then you know about phishing attacks, which we get over the email that, okay, click on this link. But you know, it's very easy to identify phishing because usually it is named like dear user or dear so and it's never personalized. But using advanced phishing techniques, even these are personalized. So in machine learning, what happens is that you observe something. You observe and then develop an algorithm to automate. So first of all, let's understand what is an observation. Okay, and now I want an active participation of my dear participants. Can anyone see? Can anyone tell me what do you see here? I know it's post lunch time. People might be sleepy, but sorry, I need an answer from someone. What do you see here? Either you can say it, you can type it, whatever. I will not move forward. There has to be a dialogue. There has to be some incentive.
It's concentric circles.
It's concentric circles. Anyone else? But do you see concentric circle in the first go? Or it looks like spiral chains, right? So it is an illusion pattern. Yes, Amarkantak, yes, you're right. It is an illusion pattern. What is an illusion? Now, our eyes have a specific domain which it recognizes very easily. The moment you move your input out of the domain, we call it illusion, right? So this is concentric circle. Another example. So this can be termed as an adversarial attack on human brain because an attacker knew that you might get confused in this picture and he gave you this picture. So try to understand from this perspective. If a human can get confused, the likelihood is very high that even machine will get confused. So this is the starting point. So whenever the input will be outside the acceptable domain, we can get optical illusion. Same is the story with ML algorithms. All the attacker has to do is to find the acceptable or unacceptable domain, and then he can have a head start. Has anyone heard about Clever Hans? Okay, so Clever Hans was a horse, very famous horse, and his trainer had actually trained him to do some calculations. He was able to do some addition, subtraction, and whenever he would do, public will clap. So how it will go? So the trainer would have the public around, the audience around, and he'll ask, okay, Hans, what is 3 plus 5? So Hans will go with his foot like, 6, 7, 8. Obviously, the people clap, right? This went on for a long time, and Hans started becoming popular. Now, someone was skeptical. There was a psychologist called Carl Stumpf. He was skeptical. He said, okay, let me give it a go and let me try and find out what's going inside, horse's mind and what's going inside the trainer's mind. So he took the horse to a dark room and he asked the question. And Hans started answering 3 plus 5. The only difference was this time Hans did not stop. He kept on knocking his foot. So ultimately, after many such experiments, it was believed that all the horse was doing was just knocking. He would only stop when he would hear the thumping sound. Now, the focus turned to the trainer. Was the trainer fooling the people? It came out that the owner actually honestly believed that he had been successful in training the horse. he was really down. He was very upset with this finding. So what does this tell us? This tells us that our actions, or the visible actions and their conclusion, they may not be right always. The initial conclusion was that the horse was doing calculation, but the actual conclusion is that horse was stopping the knocking after hearing the clapping sound. So this is where we have to be very careful in machine learning models. What we have learned so far, that reasoning behind every observable result may not always be correct. Conclusion from the observation may be wrong sometimes, even for the humans. In the same way, the machine learning is also therefore susceptible to such attacks, right? Now, how does machine learning fit here? I'm sure in last 3-4 days you have learned enough about machine learning. So in machine learning, we perform and study and research of how computer algorithms can learn and improve the data processing, how they can predict the labels or results. So just like humans make decisions, in machine learning, we are training algorithms to make decisions. There are some further areas like deep learning, which is a subset of ML, but in broad terms, machine learning is an area of a subset of artificial intelligence. Why I'm discussing these basic topics? Because the case studies that we'll be starting now will basically delve into deep learning algorithms. So we will see how deep learning algorithms are fooled. We'll see the case studies and how those patches or the complexities in the deep learning algorithms allow for unpredictability. Now, the problem with a bigger data, or the problem with larger domain, is that while you may know certain actions, there may be 100 other actions which you may not know about. This is closer to logic. So for example, if you have to find an honest person, if you have to find that there is one dishonest man among the people, how would you do it? You can write the qualities of an honest man, and you can write about the qualities of a dishonest man. And then you can find, is there an honest man in the group, or is there a dishonest man in the group? But in logic, we do not do this. What do? We write the corollary. What we say, that it does not happen. There does not exist any member who is the member of a dishonest team. So while we are writing this formula, we are writing the corollary. We are writing the reverse of it. In the same way, we have to be very careful about modeling or training our data as to what are the domains that we are capturing, and is there any domain which is being left uncaptured. We'll see the example. So from now on, the further slides show how the algorithms are being fooled, right? So this is a new field called adversarial machine learning. The idea in adversarial machine learning is, how can we trick the machine learning model by providing deceptive input? If you ever go to defense training, or if you take NDA or CDS exams, there is an exam called Pilot Aptitude Battery Test. You are allowed to take that exam only once in your life. What you have to do, you have to keep the point focused within a circle, and at the same time you are supposed to hear something. That point keeps moving. If you hear something, you have to press a button. Why this is being done? Because they want that the pilot who would be commanding the flight, the fighter plane, should be able to work independently with every sense, whether it is hearing, whether it's speaking, whether it is using his hands or legs. So he has to be able to work against all these tricks, all these threats, right? So adversarial machine learning, basically it provides us methods to generate adversarial examples. And the basic objective is to cause the malfunction in an ML model. Now, what are the possible malfunctions? One of the possible malfunction is that either we can misclassify a correct object. So maybe there is a bird, and I will say, no, this is a plane, right? Or I can classify an incorrect object. There is a plane, and I want the answer as bird, I will say this is a bird. So these are the two basic ideas. So let's start with adversarial examples. But before that, there is a term called adversarial patches. Now, within adversarial machine learning, we use these patches. These patches provide us techniques which are devised to fool the machine learning models. It can either be a physical obstruction, or it can be generated random photos through various algorithms. They have been proved high success rate against real world computer vision system. Some patches are very local. So these patches might work on certain domains also, whereas some of the patches are there which are universal, so they always work. So let's see the first example. What do you see? We have, how many persons do you see here? Anyone? In this picture, how many persons? Two, right?
Two, sir.
There are two. But what we have done is that we have put, can you see this? Oh, sorry. Can you see this? Can you see my mouse cursor, please?
Yes, sir.
Okay.
Yes.
So
Yes, sir.
this is a patch. Because of this patch, the algorithm did not classify this person as a person. Should it have or should it not have?
Should have.
It should have. Right? So this is a classic example of an attack using patch, right? Now there are many more examples in patches. So let me give you some, zoom in. Okay, is this visible?
Yes.
Okay, so what is happening here is that this is a person and we apply a patch. Now this patch is blank. So after a blank patch, he is still classified as person. But when we give this colored patch, the algorithm does not recognize. Okay, that's fine. Now, not recognizing may not be a problem, but misrecognition can be a bigger problem. So see, in this picture, this is a person and this is a bicycle. And initially, the model recognizes both the objects. We put a blank patch, and still the model succeeds in classifying both of them. The moment we put this colored patch, it's the same patch, mind it. It's the same patch that is being used everywhere. So we are talking about a universal patch in this case. It stops recognizing the person, only recognizes the bicycle. Okay, fine. There are two persons. So now the question comes, is it able to fool only one person in machine learning, or it is able to fool the whole class of labels? Let's see. So here we have a handbag, we have two persons, we have a bench, we have a dog. Okay, fine. Now we have a patch. Rather, we have two patches. Still, we have 5 objects, 1, 2, 3, 4, 5. The moment we have these two patches placed on persons, the handbag is gone and the persons are gone. So it's an attack on 3 labels, right? However, some some of them, it might not work. Like in this case, the person continued to be identified by the model. Now, in these examples, either they were classified or they were not classified. But we haven't seen any misclassification so far. So let's see. This is a person, this is a handbag, fine. Still a person, handbag is gone. And now it becomes a third thing called dining table. Right? So stage-wise, even the blank patch has been able to remove one label, and the colored patch has been able to not only remove both labels, but also allowed for misclassification of the object. In this case, it is just the removal of the label, right? So now it is easy to think, okay, this is only for, pictures, but our data is still safe. Our audio is safe, our video is safe. The machine learning algorithms will continue to work nicely on other bits and pieces. Let's have a look. This is a speech to text. So I'm speaking and someone is converting it into a text. This is the original one, where the speech to text says, it was the best of times, it was the worst of times. Now, what we have done is that the attacker has carefully crafted a noise, and the noise is only 0.001%, which is kind of not a very big noise that, algorithms will try to capture. And the moment you add this noise, what does it become? It is a truth universally acknowledged that a single or whatever. So I recommend reading a lot of literature. So I'm sure you will be given access to these slides. What I've done is at every slide, I've tried to give you the reference from where you can read the details, right? Self-driving cars are a new phenomena, and there are experiments being done at Berkeley University using deep learning algorithms. So you can see this deepdrive.berkeley.edu. They have host of such experiments. Is the browser visible or the presentation?
Presentation.
Okay, no worries. So you can go to this site and find out more. But what we are seeing here is that this is a drive-by test. Now, what do you see the sign? The sign is stop, right? What the attacker has done, or the experiment has done, is that they have put some patches over here, which can be due to pollution or due to erosion of paint, and just to see if the system is still able to recognize correctly. What they say is that this stop sign is misidentified as a speed limit sign after a while. Depends on number of frames that we process, but the self-driving cars can be fooled very easily. So rather than stopping, they'll start following a certain speed limit. Also, even if it is 20, it can be very dangerous, right? Even if it is 5, because you might have something like a lake a little bit ahead. There are some more examples. So it can be that due to fog, it can be blurry. So this is a truck sign, which is recognized as this. This is a right turn sign, but because of visibility, it is recognized as slippery road. This is work ahead. It is recognized as this. I don't remember. I think it's parking or something, but it is very easy to fool the self-driving cars by changing the resolution of the images. There are examples of fooling the neural networks. So you see, this is a school bus. When the same school bus is seen from an angle, it is recognized as a garbage truck, and that too with 99% probability. In this case, this is a punching bag, and now it becomes a snowplow. So the same object with different projections can give you a different result. Scooter can become a parachute or a bobsled, again a parachute. The fire truck can become school bus or fireboat. So the neural networks are very, very easy to fool. People have demonstrated. And, if there is an automated system, what do you do if you see a fire truck? If you are driving, then you should let it pass, right? Same is not true for a school bus. If you have a school bus behind you, or if there is an automated car, if it finds a school bus behind itself, it will not maybe give a pass because there is no such rule. School bus is in no hurry. But if it is a fire truck, the basic rule suggests that you should give it a pass. You should allow it to go by stopping in the side. That will not happen. So it's a major risk. The most famous example of adversarial noise attack is this picture. So if you read any paper about machine learning adversarial attacks, you will find this image. In this image, it is recognized as panda with 57.7% confidence. When you add a little bit of noise, it becomes gibbon with 99.3% of confidence. So it's very easy to misclassify picture, and which gives us two classes of attack categories. One is called untargeted attack and another is called targeted attack. Very, very simple. So untargeted attack, we just want, so if you ask the attacker, what is your target? Sir, I don't know. I don't have any target. I have only one target, that I do not want this to be labeled as panda. That's it. Right? So my interest lies that the answer should not be correct. That's it. So if it is anything other than panda, my work is done. We do not want the correct result. This can happen only if the attacker has access to the model. And just like we study in testing, in white box testing, we have the access to the code. Here also, the attacker will have access to the model, at least how it works and everything. In targeted attack, I'm not only interested, I'm not interested what the picture is. I want this to be something. I want this picture to be labeled as mobile, irrespective of what it is. And that is why, so we have a specific target. We know what should be the answer, right? And that is why it is target. So in untargeted attack, we want a specific correct result, but in targeted attack, we want a specific incorrect result. It is also known as black box attack because the attacker does not have access to the model. There are more attacks. So the attacker can either attack the model, it can attack the algorithm, or it can maybe poison the data. So evasion is one category of attack, which is an attack on the learned model, such as an actual classifier. So it allows it to evade certain inputs, or to give wrong weights, or to give new classes of labels with additional weights. Similarly, there is an attack called poisoning, which is an attack on algorithm itself, such as least square regression learning. So if you have been working on machine learning, you must have heard about this. So the basic objective in all these attacks remains to cause malfunction in an ML model. And as we discussed, the malfunction can be in either of the ways, either to produce a correct result or an incorrect result. So when we talk of cyber attacks or remote attacks, right? This is the most prominent one, which is data poisoning. So data poisoning takes a completely different view. So we do not attack model here. We do not attack the algorithm. What we do is we inject malicious inputs. And based on inputs, because as I understand, whatever little I know of machine learning, Is the voice not clear? Because I saw a message that voice is clear on YouTube. Well, if you want to shift to, yeah.
So it's fine, sir. Fine, sir.
Good. So yes. So the success of the model, I believe, depends on the quality of data. So if you can somehow poison the training data, then the whole conclusions will cease to be wrong. There is this joke that, when kids ask about something that we don't want to tell them, we start telling them, stories. So, what is this? Oh, no, this has nothing to do with, this is only for, adults. Kids are not supposed to talk about that. So what you're doing is, it's kind of incomplete information. And then when those kids are exposed to the real situation, they are not able to comprehend what to do, because that particular label has not been, fed into that brain. So if the attacker can poison the data, what we can do, I mean, the model should try and reject, but then again, it comes down to the possibility of whether it can identify which one is the malicious data and which one is the actual data. You have to remember that what are the powers of an attacker. So attacker can either inject, attacker can replay, or attacker can block the data. So attacker does not only need to inject the wrong data. What it can do is it can block the correct training data from going into the algorithm, so that it will never be processed, right? So one is poisoning and another is evasion, and obviously it can see the output, which is extraction. So as we said, using all this, what we can do, we can either misclassify a correct object or classify an incorrect object. So attacker can redirect the data server to one controlled by it. Let's say this is the training data. Rather than allowing this algorithm to get its training data from here, this attacker can set up its own server and then start sending the data to the algorithm from that server. So this is a classic example of a cyber attack on machine learning algorithm. What we have done, it's called simple redirection attack. In this redirection attack, what will happen is that the model or the machine will not recognize that it has been tricked into getting data from somewhere else. And it is very much possible. I mean, we all know about phishing attacks. We all know about redirection attack, right? So that's what can happen here. Attacker can also selectively remove some inputs, which it can block, using evasion. So it can stop some inputs from reaching the system. It can inject malicious inputs such as emails or domain names to classify or misclassify the correct inputs. So from here, it can inject. So this is injection, this is blocking, and then you can have misdirection. These all are the tools available to the attackers for data poisoning, right? Now, the final question. We have seen enough examples of an attack, but how can we defend? Is there any way to defend it? Anyone would like to say something on this? We know that so in software engineering, we read about something called software testing. And the moment we start reading about software testing, we also say it is virtually impossible to trace each and every control path, right? Control flow, we create a control flow graph, and then we take the shortest path and all. Similarly, since the data set is huge, the possibilities are immense, there always remains a possibility that such kind of attacks can happen. So how do we defend it? So just a reminder, what we are doing till now in machine learning is A being labeled as A? Is B being labeled as B? Right? We also need to ask two more questions. Is there anything else other than A which is being labeled as A? Or is there any possibility that A is being labeled as anything other than A? These two are very important points. So if I am Rajiv, system should recognize me and me only as Rajiv. Okay? If it recognizes someone else as Rajiv, and it is because of adversarial disturbance, then it is an attack. If it recognizes me as not Rajiv, and it is because of not because of the algorithm error, but because of some inputs or some external factors, then also it is an attack. So how do we defend? The first line defense, people have tried a lot of defense strategies, that we should add noise at the test time and see if it still works. There have been evasions and that has not worked properly. Maybe adding noise at the training time, even that has failed as proper defense. Maybe weight decay or error correcting codes, all these have not worked. So for defense strategies, first of all, we have to understand and we have to expect that there will be problems. There will be failures. And the failures would be because of something that we have not taken into account. In quotes, expect the unexpected. So if your algorithm, if your system is ready to expect the unexpected and then handle it also. When I give my students a simple code to write down, whether it is a leap year or not, they create a program. And then I tell them, okay, perform some validations, checks. I mean, you all must have done it in academics, either as a student or faculty. So when they do it and they say, oh, sir, this is working fine. 1900 is not a leap year and 2000 is a leap year, even though 1900 is divisible by 4. So they take into account all of them. When I test it, I just type A, B, C, D, and the program fails. They say, no, sir, you have entered an incorrect input. So are they correct? No. They should have taken into account that user can enter almost anything. And that is where the adversarial ML gets its strength from, because we forget to validate some of the edge cases, so to speak. So what we should be doing is we should be training the system on the actions for input beyond expectations. There are multiple defense strategies. The first and very promising one is heuristic defense. What do we do in heuristic defense? In heuristics, we learn and relearn through feedback. In the same way, we should not only train the model to correctly identify something, we should also train the model to behave properly during an attack. So we should simulate an attack situation. And during that attack situation, we should try to break the model. Till now, what has been done is that if there is a label, we have tested the model by giving it, some other picture and seeing if it labels the same or correct or incorrect labels. So the whole focus has been on correctly or incorrectly labeling everything. What we suggest now is that you should simulate an attack situation and see how the system behaves in that attack situation. If it goes beyond the expected line, you should readjust the weights and everything to bring it back to the correct ones. In this, there are no theoretical guarantees. There is another one called certified defense, where you know what kind of attack will happen, or you can simply stop the model because there is an upper bound, or then there is always this cat and mouse game, like you did something, then the attacker came up with a new attack, then you came up with a new defense, and this keeps working. And this is the third one, is the most popular in cyber attack and everything, right? So I'll give you concrete examples of two cases, and then I'll wrap it up. So first one is called adversarial training. Now, in every machine learning model, this is kind of becoming a norm that we should provide it adversarial training. What do we do in this? So if you see these two pictures, this is labeled as bird. This is not the same picture with a different resolution. So obviously the bird class has a decreased probability in this case. However, we train it that even if it is a decreased probability, you should not see anything, but you should classify it as bird only, right? That's one thing. So the basic rule here is that it relies on having labels for all the possible examples. If you have any example, label it. Whether with high probability or low probability does not matter. But do not forget the labeling. Second one is that this relies on training without labels. So what we will do, since this is an unlabeled, we will make some guesses. The guesses will be, okay, it's probably a bird, it's probably a plane, it's probably a sky. Excuse me, give me.
Sir, you are muted.
Wait. Rajiv, sir?
Yeah, sorry. There was some disturbance at the door. Okay, so yes. So in this case, since this is an unlabeled one, what we are doing is that we are saying it's probably a bird or a plane, so it will provide it some weight and some probability. What we have to do is make sure that in second case, it can still be probably a bird or maybe a plane. What we have to do now is that we should not allow to change the guess, right? So what we did in earlier one is that if we started with a label, we made sure that every possible example had a specific label. In this case, since we do not have labels, what we did is that we provided various options. All these options are, a starting point. What we are saying is that later on, attacker should not be allowed to introduce a new option. So attacker might put some patch or anything, but what we are saying is that if you have seen something earlier, if you are seeing a similar thing later on, pick one of the earlier guesses and not the new guesses, right? So these are two defense mechanisms. One is adversarial training, and then another is virtual adversarial training. So in conclusion, the adversarial machine learning is a new and emerging field of research. There are lots of examples where the machine learning is being used in cybersecurity for attacks as well as defenses. So the bottom line is that it is not only important to have the correct model, but also ensure that model is robust against adversarial machine learning. Just like in moral studies, we say, we should teach all the good things. But there is another definition which says we should not only teach the students about what is right, we should also tell them about what is wrong. So in the same way, the algorithm should not only be able to point out or define or label the correct label as correct one, it should also make sure that it never labels a correct one as incorrect or incorrect one as correct. So where does all this come from? Because every model expects a certain class of input. So if you are, let's say, expecting a model to see if I am a high net worth individual, or if I am in a middle class or a lower middle class, it will expect, some values in terms of income. But here, what we are, if you start entering only the names or the strings, I don't know how the model will behave. We should train the model to defend against adversarial patches. And obviously the defense is not very easy, as this is very tricky. So I'll like to devote some time on it. So defense is not easy because the model is trained to recognize one kind of adversarial attack, may be fooled by another designed to fool its detector. So that additional effort that you made in identifying the adversarial patch or adversarial attack, that itself may be fooled, or that may introduce some other side effects, right? Just like in medicine, when the doctor tells you, okay, this might cure your infection, but it might lead to diarrhea, or it might lead to some other issues. So similarly, we have to be very, very careful. Obviously, it's an arm race. So if someone asks me, is there a perfect secure system? The answer is no. Is there a secure system? Yes, because there is no absolute security per se. The security depends on, the chance, the risk, the probability. So if you ask me if this lock is good enough, if this lock is secure, the answer is, if I lock the door, if I go out for 6 hours, if the lock takes more than 6 hours to break, yes, it is secure. Because by the time the attacker will start unlocking this door, I'll be back. So my security requirement is only for 6 hours. That lock is fine. I don't want to spend it. In the same way, the algorithms or the machine learning should also have all such bounds. So that's it from me. If you have any questions, I'm happy to take them.
Thank you very much, sir, for a very good, very nice lecture. Participant, please ask questions to sir if you have any kind of doubt, any queries.
Hello, sir.
So there is a question, if the malicious and attacker the same? Yes. So malicious party or the attacker is same. Malicious is intent. Malicious is intent. So the question was, is the malicious and attacker the same? Yes. So malicious means with bad intention, and attacker also the same. You can use them interchangeably.
Sir, in the normal programming, we use the security like the encryption. Can we use encryption in ML algorithms or not?
So it depends on what kind of ML algorithms are you talking about. Just give me a second. Yeah, sorry. So the answer to your question is, why encryption? What do you want to safeguard against? So let's say if you have an image, right? And if you encrypt that image, what will happen? I can still change it, right? Yes
sir.
or no?
Yes, sir. Yes, sir.
If you send me your image, a password protected image, as an attacker, I can remove that image. I can send my password protected image. So encryption is not going to solve anything. It depends on the purpose. You should always think about what is the goal. So is the goal data security? Maybe, yes. But I do not see how it will fit into, the machine learning scheme of things. So if you can give me more context, then maybe I'll be able to answer it. Anything else? Any other?
Yeah, there is a one question, sir, in chat box.
Okay, let me read it. Yeah. Attackers can change the type like fish. Okay. So which type algorithm we use to train our model to remove the type of attack, because attackers can change the type, link, phishing, and many more. Again, what you can do is only to train your model in adversarial setting. So rather than waiting for attacker to attack your system, you should try to emulate this situation and see how the system behaves. Right? So rather than waiting for the system to behave irrationally, you should try and have the system ready to deal with such attacks, or to at least face such attacks and see how it behaves and what reverse actions or what actions you need to take. That is more important. Let me see if there is another question. No. Anyone else? Any other question, please?
Any more queries?
Sir, is it
You can
same
ask
as
about, machine learning. You can ask about cybersecurity, not necessarily. Yes, please.
sir? Is it same as image forgery and video forgery like that, sir? The topic you have covered.
See,
Pulling ML algorithm
image
is same. Yeah, yes, sir. Yes, sir.
Okay. It's a good question. So, image forgery is what? Image forgery is trying to change one image with another, right?
Yes, sir. Yes, sir. Maybe some part of the image or whole image itself.
Yes. What is the goal? That is the question. If the goal is that by forging that image, you have been able to fool the machine learning algorithm, then yes, it is an example of adversarial attack. Right? If it is, if it does not matter, if that image is changed, it will just add it into a repository, maybe label something and then continue. So if the changing of image leads to incorrect conclusion, I would call it an adversarial example. Is that clear?
Yes, sir. So the implementation part of this problem can be done using which software, sir, or which application?
I don't think it's about application. I think it's about modeling. So if you do the machine learning, how do you perform the training in machine learning? So it is that particular part which I'm going to attack. So if you are using Python, maybe I'll use Python, or I can do black box, right? I don't need to don't need to get into your system. All I'll do is I'll only provide the inputs. That's it. Right? I don't need to develop the system. There are huge examples of how to develop adversarial patches. So okay, it's a good question. Let me give you some examples. See, there are websites like these where you can see different examples, and there are libraries which it supports. It has a lot of classes of attacks. There are adversarial patches. So you can go through them if you want. I'll share the link. Right? So if you are interested in developing and using it.
There is one question, sir. There are any time duration to find out cyber attack?
Any time duration to find out cyber attack? How do you find out if there has been a burglary in your house? Right? So the answer is as simple as that. When do you check it?
Any more queries, participants? Anyone? Okay.
I mean, you can ask from cybersecurity, you can ask from machine learning and cybersecurity. Does not need. And please give me some honest feedback. If someone can give me, how can I improve, or how did you like it, not like it, anything.
Any more queries, participant? Ruby ma'am, are you there?
Sir. Yes, sir.
Okay, okay. Thank you so much, sir, for your very good and brainstorming lecture. Now, I would like.
We still have 10 minutes left. I expected some questions, and that is why I kept like 10 minutes for question. But anyways, yeah.
Hello.
Okay. Yeah. Now, yeah. There is I think someone is asking something.
Yeah, sir. Good afternoon, sir.
Yes, ma'am.
Yeah, good afternoon. I am Dr. Thirumalai Chelvi from Chennai, Government Arts College, Nandanam. Sir, really,
Yes,
it's a
ma'am.
very interesting session. Actually, in machine learning, we know supervised and supervised learning and assisted algorithms only. But it's really a good topic. We don't know about the attacks in machine learning.
Thank you, ma'am. That is the idea.
Yeah, really.
As I said in the beginning,
yes.
I don't want to make you a specialist of something in 1 hour,
Yes.
but I just wanted to give you a new flavor into an area which I know is very not talked about much in detail. So many a times we should try and get acquainted with newer and newer areas which can help us widen our research and study horizon. So thank you, ma'am, for your
Sure, sir. We haven't heard so far that word at all. Adversarial. Sir, how far it should be useful for our research work, for our scholars in machine learning or some other? Only for security purpose attacks only we are using. Is there any algorithm separately?
No, ma'am, it is not only about attacks. So it is, first of all, try to understand this is not about cyber attacks, right? It is adversarial attacks. And adversarial attacks simply means any action done with the wrong intent. What can be the wrong intent? That someone can be misclassified or something wrong. So you are in a college, okay? In your college, what you want two things. A student should only be able to write his own exams. And no one who is not a student should be able to write the exams. And now you have a automated machine learning system which can identify the students and all. If anyone tries to break into that system, using whatever means, does not necessarily need to be a cyber attack. The best example of this I'll give you. Student said there was a question paper. Who is the Prime Minister of India? And someone wrote Ramlal, right? He got 0 marks. He went to the teacher. And the teacher said it's a wrong answer. And he said, ma'am, but I looked it online. Right? And in online, it says the Prime Minister of India is Ramlal. On some of the website. Can you stop me from doing that? So what did the attacker do, or what happened there? That rather than going to the official website, I forwarded this information from an unofficial website. The research, that the answer that you get from Google, is it true? No. The answer that you get from Google, it's a search engine. It gives you, I mean, right now Google has become very intelligent, but 5 years back, it would only give you the link where you can find the answer, not the answer itself. Now it has started giving the answers, right? So if your link is wrong, so if I can feed the database with the wrong information, the answer will also be wrong. So how to protect my data, how to protect my algorithm, how to protect the result. We can talk about everything, and we can do some research. Yes, very good question.
Okay, fine, sir. Thank you so much.
I
Okay,
think there
any
is.
more queries?
Yes, yes. I think there is someone. Okay. Yeah.
More queries? Any more queries, participant?
I'm happy to share my email if you have any queries.
Yeah, please share it, and please share your PPT also, sir.
Yes, I will email you.
Okay, sir has shared his email address in chat box, rrsingh.du@gmail.com. If you have any kind of query, you can text to me also.
Even if you write Rajiv and you
Sir,
say Delhi
excuse me,
University,
sir.
then all my information is online. So.
Yeah, again, excuse me, sir, myself only. Sir, is there any special tutorial or book or anything regarding this advisable trade attack?
Yeah. If you go on YouTube, there are 3 or 4 very good videos. If you just type adversarial machine learning, there are some Stanford, some Google videos, and they're really technical. Okay, so there is one question from Jiva Ratinam.
Okay, sir.
How do we know the source of malicious software? There are various ways to know the source of malicious software. So when the system downloads any software, there is always a log. So you can check the log, and from there, using forensics, we can know.
Okay, I think sir have given the most of answer of the most of queries in a very nice manner. If you have any queries, still you can ask. We have 2 or 3 minutes more. Okay, so now I would like to request Ruby ma'am to propose a vote of thanks. Ruby ma'am.
Sir, it's my privilege to give vote of thanks to Rajiv Ranjan sir. I thank you for very insightful and engaging session where we not only were entitled with adversarial attack examples, but are also taught multiple defense strategies to be adapted with more need for adversarial training to adversarial machine learning as emerging field of research. Thank you, sir.
Thank you, ma'am. Thank you for the invitation. I wholeheartedly thank Abhishek sir, Pawan sir,
Thank you, sir.
and every participant who made it interesting. Let me say this out loud. I get invited to various webinars and all, but this was really an effort. Disclaimer: I'm not a machine learning expert, so but I'm from cybersecurity. But this one is an emerging field. And that is why I thought that I should introduce to the larger audience, because I haven't seen this topic being talked about in our current research literature. So if anyone is interested in collaborating with me for further research, you can share your proposal with me, and I'll be more than happy to work alongside. Maybe learn a lot.
It was very effective session, sir. It was really nice session, sir. Thank you so much.
I hope people enjoyed it. I hope people got something from it.
We have also enjoyed, sir. It was indeed it was a very good lecture, sir. Thank you so much.
Thank you very much, sir.
Thank you.
Please, I have sent you a receipt, sir, and please share your PPT and receipt.
Yeah. I'll do that later today. I now have got lectures, 2-3 lectures. So after that, I'll do.
Thank you so much.
Thank you. Have a great day.
Okay, participants. The next lecture will be started at 2:50. We have 10-minute tea break. Okay.
Sir, excuse me, sir. Sir,
Yeah.
sir, in attendance, since I don't know how to enter the time. When I enter AM or PM, it shows invalid time. I have the problem in the morning also.
Listen, ma'am. Actually, I have given separate link for the morning and evening attendance. Okay.
That is not a problem, sir. While entering a session PM means it said it's a not invalid time. In the afternoon attendance only, I am telling you, sir. Please.
I'm not understanding what you're telling me. It is regarding the attendance, ma'am.
Sir, in the attendance link, when I enter the attendance, while entering all the details, date and time column will come. No, in the
date and time, ma'am. Date and time.
There is no.
Date and time is regarding at which time you are filling the attendance only.
Okay, today's date, in the menu I have taken the today's date.
Yeah. At which time you are filling the attendance.
For time, sir, what should I enter? AM and PM only it shows.
But the time you are filling, okay?
Okay, so I have to
There's
fill the time. What time? The time.
in morning it will be AM and evening it will be PM automatically.
Okay, sir. So I have to enter 2:30 or 4:20 like that. I have to enter the time.
Yeah, ma'am. Yeah.
Thank you, sir. Now I understand.
Thank you
sir.
very much. And we will join, okay, at 2:50. Okay. It will be going to a very nice lecture delivered by Dr. Indranath Chatterjee. Okay, he's from South Korea. Okay. So please have patience and be there. Okay. We will back within a 10 minutes. Okay. Thank you. It's a tea break for 10 minutes. Namaskar, sir. Namaskar. Indira, sir. Namaskar. Chatterjee, sir, are you there? Please
Yes,
unmute your.
yes.
Please open your camera, sir.
Yeah, let me just. Yeah.
गुड आफ्टरनून सर। कैसे हैं?
सर कैसे हैं आप?
बस फाइन सर, आप बताइए आप कैसे हैं?
बस अभी थोड़ा सा बेटर।
हाँ, राइट सर। Actually, it is very difficult.
Yes. Participant. So, dear participants, am I audible to all?
Yes, sir.
Okay, very good afternoon to one and all. For the next lecture, today's resource person is Dr. Indira Chatterjee. Is from Department of Computer Science and Engineering at Tongmong University, Busan, South Korea. I would like to request Dr. Abhishek Bansal sir to introduce Dr. Chatterjee.
Okay, sir. Okay, thank you very much, sir. It is my honor to introduce eminent Professor Dr. Indira Chatterjee. Dr. Indira Chatterjee is working as a professor in the Department of Computer Engineering at Tongmyong University, Busan, South Korea. He received his PhD degree in computational neuroscience from the Department of Computer Science, University of Delhi, Delhi. His research area includes computational neuroscience, schizophrenia, medical imaging, fMRI, and machine learning. He has authored and edited more than 8 books on computer science and neuroscience published by renowned international publishers. He has published numerous research papers in international journals and conferences. He is receptionist of various global awards on neuroscience. He is currently serving as a chief section editor of a few renowned international journals and serving as a member of the advisory board and editorial board of various international journals. Dr. Chatterjee is an internationally acclaimed advocate of open science. He is personally working on several projects of government and non-government organizations as PI and co-PI related to medical imaging and machine learning for a broader societal impact in collaboration with several universities globally. He is an active professional member of the Association of Computational Machinery, ACM USA, Organization of Human Brain Mapping, OHBM USA, Federation of European Neuroscience Society, FENS Belgium, Association of Clinical Neurology and Mental Health, and International Neuroinformatic Coordinating Facility. So, sir, with this brief introduction, I welcome you, sir, and invite you to deliver a lecture on natural language processing. Sir, over to you, sir.
Thank you so much, sir, for the very warm welcome, and really thank you for inviting me to give a talk over here. So it's my privilege, but I'm really sorry to reschedule my talk from 25th to 27. I'm thankful to Dr. Pawan also for allowing me to reschedule because it was very severely affected COVID that time. So now
Yes,
I'm
sir.
fine, and I'm really happy to present my today's lecture. So, so may I start?
Sure, sir, sure.
Okay.
Please, sir, please go ahead.
Yes. So let me just share my screen. Please let me know if the whole full screen is visible.
It is visible, sir. It is quite visible. Please start your slideshow.
Yes. Let me just slideshow. Is the whole full screen visible?
Yes, sir.
Yes, sir.
Yeah. Okay.
Please go ahead, sir.
Thank you so much. So welcome everyone. So today, as instructed by Dr. Abhishek, that I'm going to give you a presentation on the natural language processing, and it's a field of AI, ML, DL, and all these things. I'll describe you in detail in the upcoming slides. So before getting into the detail of the natural language processing, we have to know that what we are going to cover in this talk. So natural language processing, we see the aspect of the future of communication. We'll see the different perspective. We'll see the different dimensions of it, of different aspects that we usually work with natural language processing. So I'll try to finish it within 1 hour. And if you have any question, you can, in the meantime, you can drop your messages, your question in the chat box. And if I get a pop-up message, I'll reply you soon. So as I told you that when we talk about the natural language processing, we come up with a mind that the future of communication. So when we talk about the future of communication, we obviously think about the different aspects of communication. Like it can be a kind of oral communication, verbal communication, it can be a written communication, electronic communication. So all these kind of communication, we mainly divide the communication into two parts: the medium of communication and ease of communication. So we are not talking about the medium of communication here in today's lecture, because we are all aware of the different kinds of communication media, but we will talk about the ease of communication. So ease of communication means how well we can make our communication easier for our better future communication. So what is the future that comes up when we talk about the communication structures? Like, for example, when we talk about the man to human communication, when we talk about the human to machine communication, when we talk about the machine to machine communication, so it needs to be very much advanced in a way that we are dealing with nowadays, with huge amounts of multiverse communication, what we say from different dimensions, right? So here we'll gradually look after about the different ease of communication. So when we talk about the communication, the first thing that came up in your mind that it's the human language. Now you can tell us that, okay, what is the special about human language? Why do we need human language to learn? Because human language must be very easy, that we everyday speak and we communicate within each other with the human language. But trust me, human language is the most ambiguous, and it's a very difficult kind of language, like what we are dealing with any kind of programming language or formal languages. So they are very much ambiguous. So it's a very specifically constructed language, or maybe we can say a kind of prototype, or a kind of thing that we use to convey some kinds of meaning. So as we know that the little kids, when it's try to learn a language, maybe any kind of language, it's mother language or the any foreign language, any kind of language, when the kids try to learn, it try to learn with different kinds of verbal expressions and different kinds of bodily expressions, right? So human language is a kind of discrete, symbolic, and categorical signaling system, presumably because of greater signaling reliability. That means when we human talk, we never talk with just only with our voice, right? We obviously use different face, different what can I say, different face expressions, different body gestures, different hand gestures, different tone, different sounds, and different writings. So we express our feelings, we express our words with different kinds of expression, along with the vocal tone or the vocal voice that we speak about that particular language. So it's very ambiguous, because like I told you, so not only with the help of the word, with the help of the hand expression, face expression, eyebrow expression, eye expression, and all these things, we can decode the language in a different form to each of the person, right? So now ease of communication that I was talking about. So that ease of communication is very important. For example, every one of you have known that for a better verbal communication, you have to be speed more sophisticated way, more interpretable, more productive, and with less error. So for example, this person, when it comes for an interview and the person asks something and he's saying so much of thing all together that this person is thinking, oh my God, this person must be a crazy person. So he's just pressing the alarm button. So it feels, so when your words are not well, are not well interpretable, are not more productive, and have a lot of errors, have no meaning, have no proper sentence formation, this communication, maybe in a good English, maybe in a good language, maybe in a good Bengali or whatever the language you speak, but if the language is not properly comprehensive, then it is not properly interpretable, then it's not a good way of communication. So when we talk about the communication and all these things, before starting the core NLP part, so I want to briefly get you to the concept of NLP, that why NLP is important and what is NLP and all these things. So before we learn about the NLP, we have to learn about the L, that is the linguistic. So linguistic is a very systematic study, or a very scientific study, we may say, which study the structure and evolution of human language. So it involves many different kinds of studies, like the phonological study, the morphological study, semantical study, a lot of studies which deals with the linguistics, and it's connect with different other kinds of subjects like the psychology, anthropology, neuroscience, human psychology, philosophy, computer science, and all these things are very much connected with the linguistic. Now, when we talk about the NLP and when we talk about the linguistic, the computational part of the linguistic is what we call as NLP. So computational linguistic is a scientific and engineering discipline. It's not not the humanities department, not the philosophical part, but the engineering discipline, which concerned with understanding of written and spoken language from a more computational perspective. So theoretical goals of the computational linguistic includes the formulation of the grammatical and the semantical framework and characterizing the different languages. So development of more cognitively available and neuroscientifically plausible computational models to understand the structure and the evolution of the language, to understand the basic, the scheme of the language within the particular kind of the structure is very important in that. So computational linguistics actually helps in that. So with the help of computational linguistics and with the help of AI, we build a new kind of technology called natural language processing. So for any layman, for example, if I just take a grant that 80% of you are not aware of the natural language processing, even though if I ask you that what is natural language processing, what do you mean by the natural language processing, you will eventually just blink in your mind that natural language processing must be something like the autocorrection in the Gmail, or the auto for the automatic form filling in the Google, or the automatic typing in the Google, or the Google translation. That's the most important part which you mind, or the IBM Watson, or the Alexa, or kind of thing, right? So whenever kind of talk with the natural language processing, you will get into mind of these technologies. Yes, you are absolutely correct, because these technologies are the core or the daily usage visibility of natural language processing. That means in everyday life, every day we are using the technology built up by natural language processing, and we are using it on everyday basis. So the natural language processing is a field of computer science, AI, and computational linguistics. So it's a three kind of subject. So we use the basic computer science technology, mathematics, and the different mathematical probabilistic thing, and automata theory. And then we'll take the new advanced AI models like ML and DL, and we use the traditional linguistic technologies to build a NLP model. So now we have to know that why do we need to learn one more subject, natural language processing? You know, we already have a huge, innumerous number of subjects in computer science that we need to learn, and it's a huge thing, computer science. So we have like undifferentiated number of subjects which we can really touch, and we can actually explore that. But why do we need a new thing in computer science? So when we talk about the future of communication, when we talk about the ease of communication, we are not only in a plan to make a easier for a human machine communication, but also improving the human communication. Now you will ask that, okay, I can understand, like when we're dealing with the robots, when we're dealing with the robotic, any kind of instrument or the machine, we have to depend on the human machine communication, right? But when we talk about the, why do we need human communication? Because from like centuries and decades and all, we are well behaved, we are well sophisticated to talk about own human being. But no, human communication is very important, and also NLP is helping in that. For example, when you are writing something on MS Word, so you can just switch on the Grammarly, for example, the Grammarly toolkit in the MS Word, and you are writing some letter, and that Grammarly, which is a product of NLP, is actually helping you in a real time to improve your writing skill. That means if you are writing something in any language to a person, that language can be improved for a better understandability, for a better interpretability to the another human being. So that's the product of natural language processing. Machine translation, and it's a everyday usage of the machine translation, which is also a product of natural language processing. Now let us understand that why NLP is interesting. So language involves many human activities, right? Reading, writing, speaking, listening, and voices that we speak use can be a user interface in many applications. For example, for the remote controls like virtual assistants like Siri, Alexa, and all these things we use our everyday with our phone, with our personal assistant appliances and all these things. So these are all depends on NLP. Now, for example, we use NLP to acquire insights from huge amount of data that we are generating every day. For example, from the medical records, from the health records, for example, the doctors, we are passing by the different patients and the different patients' beds, and the e-nurse, which is also somehow common in few hospitals in Korea and something like that. The e-nurse, or the it's not typically the nurse, it's kind of a robot which stands or which sits beside of kind of patients, which actually store the everyday records and everything. When a doctor makes the rounds around the patients and looking, and they are just saying the telling the different biomedical data, biomedical records to the to save it, instead of just writing it out, and it saves and it analyzes whole day, and it also checks with the regular in real time, also in the real time structure of the biomedical data, and it also what can I say, it also analyze them and make some productive results. So but I'll tell you that yes, we need to learn about NLP, and NLP is everywhere right now, but still NLP is hard. Now I'll tell you why NLP is hard, and why do we need to learn NLP in a very deep way. For example, let's take a very famous example, like I made a duck. So this is a very small sentence, right? I made her duck. Now think that why NLP is really hard. I made a duck can be semantically can be formed into different other sentences. For example, I cooked waterfowl for her. Duck is the like this, like a chicken kind of thing, right? So I cooked waterfowl for her, or I cooked waterfowl belong to her, or I created with a plastic or any machine or any kind of thing that she owns. or I caused her to quickly lower her head. That means to duck something. I caused her to quickly lower her head or body to pass some bridge or something like that. I made her duck. Or I waved my magic wand and turned into an undifferentiated waterfowl, which is a kind of impossible thing to a human being. But okay, this sentence can be semantically broken into 5 or more meaningful sentences, right? So can you imagine this sentence, even for a human being, can be so ambiguous? That is, I made a duck, and it can be differentiated. It can have many meanings, which is also very much disturbing or very confusing for a human being. Now think that how hard it is for a computer to understand. So to do research with NLP, you have to be very cautious about the different semantical meaning. So in the same way, the example like the I saw her duck, it can be like I saw her, she was ducking, or I saw her who was taking her duck for a walk, or the chicken is ready to eat. So when we say that the chicken is ready to eat, it either means that the chicken, the recipe of the chicken is ready, it is ready for eat, or the chicken is sitting in the dining table to eat, which is obviously not. But for a computer, it is undifferentiable. That is, computer cannot understand which is true or not. So for the computer, both the thing is correct. But we need to improve the NLP, we need to improve the model and the technology for a better understanding of the machine. For example, call me a cab. Okay, you are a cab. So call me a cab means call a cab for me, or my name is cab, call me a cab. So this way NLP is really hard. Now, another example, which is very funny and very famous example in NLP. So this example is, why is NLP hard? That means the famous sentence is, I shot an elephant in my pajama. So now this has two meaning. Either that I shot an elephant while I am wearing a pajama, or I shot an elephant which is wearing a pajama. But for a human being, the next thing is impossible, that an elephant cannot wear a pajama, but for a human being, the first one can be an answer. But for the computer, it is really confusing, because for computer, the elephant can be an animal, or elephant can be any person whose name is elephant, who is wearing a pajama, or the person, that is I, is wearing the pajama and shooting the elephant. So in this way, it is really very hard while we deal with the NLP from the core level in the computer. So for this thing, we do the parsing tree that I'll come in the later slides. So it is not possible to cover the every parts of the NLP and the core technology of the NLP in 1 hour lecture, but I'll try to touch the every sort of the technologies and explain you that how we work with the NLP. So now natural languages are highly ambiguous, that we told you, that I told you, right? So we have different kinds of words meaning, we have different kind of syntactic meaning, semantic meaning, and obviously the discourse level. So natural languages are fuzzy. That is, when we talk about the examples like the I shot an elephant in my pajama, so it was very unlikely that the elephant wears a pajama, but it is likely for me to be wearing a pajama while shooting the elephant. So, but it is ambiguous for the computer. Although we came to know and talk about the NLP in recent times, but NLP is not new. The main foundation of the NLP started in the early 1950s. So when the first automation theories and different paradigms like probabilistic and information theoretical models were built in 1950s, it started since then. That time was not exactly the NLP, but it was starting of the linguistic. So from the linguistic model, or precisely the computational linguistic models, it started. Then we have in 1970s and 1980s, we have different stochastic paradigm, logic-based paradigm, language NLU, which is the natural language understanding, and also the different finite state models which built up in the early 90s and late 80s. So with the rise of machine learning algorithms from the 2000s, the NLP become very popular, because in the 90s or in the late 90s or the early 2000s, we have a huge number of data we have, like there is a transition from the floppy disk to the CD-ROM, then the DVD-ROM, then the pen drive, disk drive, then the solid state devices, and all these things. With this kind of transitions, we have a storage capability of a huge number, and with a large number of storing capabilities, we have a huge data available to us. So with this data, and with the help of the machine learning algorithms which were rising at that time, and it was a transition part it was a kind of renaissance for the NLP period. So where is the NLP right now? Now you should know that you can say, okay, we have achieved every part of NLP. No. If we consider the NLP, we have divided into 3 different stages, like the machine consciousness, which is the stage 1, which we have already covered in the NLP evolution. Then the machine intelligence, which we have already covered, and the machine learning, that is the 3rd stage with the different Siri, Alexa, Cortana, and all these things. Now you should ask that we already have developed Siri, Alexa, and Cortana. So aren't we here? No, we are not here at this stage in terms of NLP. In terms of the stages of AI, we are still here in the machine intelligence, because Siri, Alexa, Cortana, these are still under development, and it is not yet so much advanced that we use. But yes, it is quite usable right now. We can use Siri, Alexa, and everything in our daily life. So how does AI and NLP linked? So the AI is a subfield of computer science, which is a kind of interdisciplinary subject. And when we talk about the text processing, speech processing, we can say, okay, we can already work with the speech processing, with the signal processing thing. We can already work with the text processing, with the different data mining technology. Then why do we need the NLP? When we talk about the speech, that is a voice, direct voice, and we need some real-time technology to understand that meaning of the voice, not the technological or the signal processing part of things. Then we need the NLP. When we need the text data, mostly the textual data, that is unstructured data we have to work with, then we have to need the NLP. So NLP can work on huge amount of data, and large amount of data requires more NLP expertise. So right now NLP is everywhere, every other company. For example, if you or your students may start learning about NLP, so there's a huge prospect for the next 2 decades indeed for the career in the NLP. Like every second company right now is using the NLP in some part of the other of their business model. For example, Yahoo, Google, Facebook, Twitter, and everyone is using the NLP for everyday purposes. Now let's dig deeper into the NLP and see like little technological part, and with the help of some of the examples that how does we use the NLP in our daily life. So why do we need to learn NLP? So for example, you are going through a car, you are going in your car or in a bus, and you just listen to some song, just a middle of a song, like only 2 or 3 sentences, or maybe just a sentence in the middle of a whole song, and you don't understand, you don't know the starting point of the song. There's a mukhra of the song, right? So what you do, you cannot search that song, or you don't want to search that song. What you do, you just ask your Alexa or your Siri to just search and find that song, and listening to that, only that part, it will try to find that song instantly for you from all over the internet. So this was the best example that we use every day now, virtual assistants, like we use Siri, Alexa, Google Assistant, and all these things for our everyday easiness. So sentiment analysis, text classification, chatbots are also the examples of NLP, which we use every day. And different sectors that we use, for example, the banking, insurance, healthcare, retail, we use everywhere this NLP this time. I will in the last part of my lecture, I will also give you a huge description which you can take a screenshot, where you can get a lot of research areas. Where you start working on NLP, you can finish your whole PhD as well. So let's take an example of this demo. I don't know whether it will, you will hear, you will know the sound or not. So this is a small example, like how we use Alexa on an everyday basis. I know a lot of people have the Alexa with you, but it's the example like how we are more dependent on NLP in our daily life. We can call our Alexa to switch on the fan, switch on the TV, and every appliances in our home are right now the smart appliances, and we control, we ask them to run, to slow down, to get faster, to change the channel, to have a volume up, volume down. It has everything what with just with the help of an asking the Alexa. It can be Alexa or a Google Home or kind of any kind of
Alexa
thing.
turn on channel 9. Alexa, it's cold. Alexa, it's cold.
So when it just say that Alexa, it's cold, the air condition automatically switched off. So it's like that. So it's not only listen to your demand. It not only listen to your questions. It also understands your feelings. It also understands the thing that you are really want to express to the different parts. That means, for example, when we're asking for the Alexa, I'm not feeling well, the Alexa try to understand my mood and try to cheer me up with some of the good news, or some of the jokes, or some of the nice music. It tried to cheer me up. So this is how we actually these kind of NLP thing is important, and this is our responsibility, the responsibility of the computer scientist to improve this thing for a better tomorrow.
Alexa.
NLP is everywhere because the textual data or any kind of data which requires NLP is everywhere. So this is the just generic structure that I have taken from the Google randomly today, and it says that for every 1 minute, just every 1 minute, it's 3.3 million Facebook posts are being posted. 500 hours of YouTube videos are uploaded just for 1 minute. More than 29 million WhatsApp messages are sent in just 1 minute. And more than 65,000 posts are being uploaded in the Instagram. So can you imagine the huge number of data? It's exponential. It's not only exponential, it's more than exponentially increasing every day, just in a just blink of seconds. And all these data are being stored in the cloud somewhere in the world. And we are all superfluously this data, we are all overflowed with this data, and we the data scientists, we need to dig out we need to understand this data, we need to dig in into this data, that we actually need to understand that what the whole world is doing right now. To understand the entire world, we understand the mentality, to understand the psychology of the human being, we have a ample opportunity to understand all these things. And believe me, all these things are publicly available. All these things are publicly available data. So we can use our NLP technology to understand and do a lot of things. And these things need, so for that thing, the more and more stable and robust NLP algorithms is very much needed. So let us see some of the everyday examples of NLP. So as I told you, the email filters, which we always do every day. For previously, there was, for example, only one email filter. For example, the email has no proper salutation, the email has no proper address, proper signature, or proper characterization, then the email automatically goes into the spam folder. But nowadays, the Google has also more technology that it can also sort your emails in different part, like the updates, forums, and official, and whatever the tag you want to add, it will automatically categorize your email before you open it. That means your Google server reads your email even much before than you do. So they just reads your whole email messages, and in a blink of second, it just read all your thing and apply the NLP, understand the message, understand the context of the message, and send it and categorize it to a kind of class that it's a it's a updates email, it's a kind of promotion email, it's kind of forums email that comes from different social media or something like that. So this is how we actually emails are being filtering, and NLP is helping us in every day. Smart assistant, which I already told you, like different thing like the Siri, Alexa, Google Assistant, Cortana, and all these things are helping us every day nowadays, and we are more dependent on this. We have to ask something, we just say like, hey Google, hey Siri, or hey Alexa, we just tell me these things, and we are getting everything in just a blink of seconds. So we are not relying also on the type and Google search with these things. This is another example. So can anybody just tell me that if they are able to listen to the last video, then I will play it again. This is an
Yes, sir.
example.
We could hear.
Okay. Thank you. Then just try to listen to this audio clip. So this is a very, very unique and very nice example of the how advanced the NLP has become nowadays. So this is an example of the latest version of the Google Assistant, where the Google Assistant is so smart nowadays. They can not only they can dictate something, they can already talk to a person in a real time, in a real person with a real tone, and they have some real human expressions and all these things. They can take the decision also. They can understand, they can decide, and they can do the task that you have ordered it to be done. So just listen to it. Here actually, for example, the person instructed his Google Assistant to book a hotel, book a restaurant for say 3 or 4 person for some particular day or date, and the Google Assistant, in the meantime, in any time of the day, whatever, the Google Assistant automatically in the background automatically call the real hotel manager and book it for you. Just see.
Can I hear you? Hi, I'd like to reserve a table for Wednesday the 7th. For 7 people? It's for 4 people. 4 people? When? Next Wednesday at 6 p.m. Oh, actually, we reserve for like after like 5 people. For 4 people, you can come. How long is the wait usually to be seated? When tomorrow or weekday or? For next Wednesday, the 7th. Oh, no, it's not too busy. You can come for 4 people, okay? Oh, I gotcha. Thanks.
So see here the Google Assistant is actually talking like a real person, and it gives some real colloquial expression like a normal human being while talking to the real hotel manager for the booking of the person. So it's not only just text. Nowadays NLP is helping the different technologists, like not only sending a text message to the hotel that please book a room or book a table for 4 person on next Wednesday at 7 p.m. It also talks to them in the background when you are not present, and it can talk like a person. So this is just a small example of the current technological advancement of NLP. So this is another example, everyday example of the NLP we use. That is a search letter. That is auto completion, right? Whenever we start to write, like how to, and we get to get the whole kinds of we'll get to get the whole kinds of sentence automatically coming in the Google. So when you start typing something over Google, that okay, how to do this, and it's show us all the probable, the next sentence or the next word we may need to search for, right? So the search engine uses NLP in a real time to help us understand the understand our search, or to help us getting our results in a very very easy way. Language translation is one of the tremendous revolutionary changes that makes human life easier. For example, when we are talking in a real time, so it's like a savior for the person who lives, like for me, the person living in South Korea. I don't talk in Korean much. So for me, it's like a savior for me while I'm traveling and I'm doing everything just with the help of Google Translator or the Papago translation. So for example, I'll reply to you. So to talk to the hotel manager, for example, you just say, for example, the Google Assistant, just say the Google Assistant that, okay, Google Assistant, please reserve a hotel for me or restaurant table for me for this person, this day of time. You just store the information, just saying or typing whatever you want to do, and the Google Assistant will do the rest to book that. Okay. So the machine language translation or the machine translation is a huge thing. So the magical part of the machine translation or the language translation is that it not only translate word by word, it also try to maintain the linguistic structures. It also try to maintain the grammatical structure of the word. For example, the grammar in every language is different. For example, in some language, the verb comes in between. For in other language, the verbs comes at last, right? So, for example, in English, we put verb in the middle. For in Hindi, Bengali, or in most in Indian languages, we put verb at the last. So this is the difference between these things. But NLP is so advanced, the machine translation is so smart these days that it can really, it not only translate that thing exactly in the another language, but also try to maintain the grammatical structure of the language. Text analytics or the sentiment analysis, or the text analysis involves a lot of different things. So in the text analysis, we use the sentiment analysis, which you have already know a lot of things about that. And we use different reviews, different feedbacks, different comments to understand the human behavior, to understand the human psychology, to understand the human views and their sentiments about something or other. So all these are the examples of NLP. So now let us explore some technical part of the NLP, but in a very short, I will not take much of your time. So in a very short, I'll explain the core part of the NLP. So for example, when we start learning NLP, the most important and the basic 4 parts which you need to learn just for starting. Okay, if you want to start NLP from today and you want to understand that how how we actually help in understanding a language. You can take any random data from the GitHub or something. You can you can take any simple code from GitHub or something and run in Python or something, and if you learn this only 4 parts, you can do the basic NLP task. So the basic 4 NLP tasks are the word segmentation, POS tagging, syntactic analysis, and semantic analysis. So I will explain very shortly about each one of them. So what is word segmentation? So word segmentation, we usually call this as tokenization when we talk in the NLP terms. So word segmentation is a tokenization. But there is a problem in some languages. For example, in Japanese, for example, in Vietnamese, there was either no space between the words or a word may contain the smaller syllables. So in that sense, the computer gets problems. So they don't understand that where the word ends or where the word will end. So for this kind of problem, so we have a possible solution is called a maximum matching problem. So when we have a maximum matching problem, that means we have a kind of dictionary with us, and we have a kind of already preloaded hash values with us, and we try to search the words by words. We try to find that which word is actually matching the sentences. For example, in this Vietnamese sentence, that's Nath Van Luon. I cannot read Vietnamese, but I can just read it out. So in this sentence, we don't know that what this word is. It is Nath Ban or Nath Ban. So both are actually the legal words. So when we talk about the Nath Ban Luo is the sentence, we see that a Nath Ban is a word in a dictionary, but not Lath Ban Luon is. So that means this is a word and here it ends. So we can segment this word with the help of maximum matching. But for English, it does not have any problem. For Hindi, Bengali, it does not have any problem because we have proper system of space between each of the words. The next thing after the word tokenizer or the word segmentation, we usually have to apply the POS tagging. So actually these are the steps. For example, when we start learning NLP for the first time, you need to understand that what are the basic steps we need to learn. So NLP is a huge thing. It's a year-long, semester-long or 2 semester-long subjects which you can learn, and it has a huge dimension to learn on. But to start with, you can take these small steps like the word segmentation, POS tagging, the syntactic analysis, and semantic analysis. If you just try to learn these 4 different things, I promise you, you can learn NLP from today as well. Or you can also work on NLP. So I will also share my book that I have written on NLP. So you can also get that book, and you can learn about the NLP in a very easy way. So POS tagging, it's called the parts of speech tagging. So first part was word segmentation, that is tokenization. That means we have a sentence, we tokenize the word. That means we segment the word by word, one of them, and we keep those words as a entity. We call them as an entity, small words, okay? And we call them as terms. Now what we have to do? Now, as a normal human being also need to understand the grammar of the sentence, computer also needs to know the grammar of the sentence. And what was the first thing we need to learn in a grammar? It's the parts of speech, that is noun, pronoun, adjective, and all these things. Computer also needs to learn the POS, that is the parts of speech. So we have to tag each term, each words, and with its corresponding parts of speech tags. For example, the sentence that is that the grand jury commented on a number of other topics. So when we apply the POS tagging over here, we actually tagging the parts of speech for each words. For example, the is a article or determinant. The grant is an adjective. The jury is a noun. The commented is a verb. On is an interjection. A is again an article or a determinant. Number is a noun, and so on. So in this way, first we tag, we tokenize each word. Then we assign the parts of speech tags to each words. Okay. So the two stages are gone. Sometimes there is one technology in parts of speech tagging. We call it as a sequence labeling. So what is sequence labeling? There is some problem in some sentences where the parts of speech or the POS tagging can be a problematic. For example, the sentence that is John saw the saw and decided to take it to the table. John saw the saw and decided to take it to the table. Now here for a human being, it is confusing, but still we know that the second saw is the kind of saw, a kind of instrument which helps to cut a iron or cuts a wood or something like that. Okay. So the John is a person who saw the saw, that is the instrument to cut the wood, and decide to take it to the table. Maybe it was on the floor and it can cause a accident, so it's decide to take it to the table. But for a computer, what is John is a noun, saw is a verb, decide is a verb, and all these things it needs to learn. But when we talk about the sequence labeling, we do a kind of windowing thing. That is a kind of sliding window thing. That is, John saw the saw and decided to take it to the table. We do the first window over here, and we see that the John is a noun, saw is a verb, the is a determinant, and next saw is a noun. Then now how? Because the verb never comes after the, right? So if a verb is there just after the determinant, then it must be a noun. So this is how we make the computer understand that the first saw is the verb and the second saw must be something which is called as saw. So in this way, either by in the normal way or in a complicated sentence like this, we do a sequence labeling, and in this way we'll do a parts of speech tagging. And the third step is the syntax analysis. So syntax analysis is very important because in every programming language, we know we used to get a lot of syntax error, right? So when we get a lot of syntax errors, which comes like for full stop, comma, semicolon, question mark, exclamation marks, and all these things. Here also syntactic analysis or syntax analysis is very important. For example, my dog likes eating sausages. So syntax analysis is what? So first, what we do, we tokenize each word over here. Then what we do, we assign the parts of speech. Then we try to see that the sentence is properly structured or not. That my dog likes sausage also eating. Is it a correct syntax? No. Then my dog also likes eating sausage. Okay, this is a correct, and it ends with a stop. So this is a correct. So we use the parsing tree technology. With the help of parsing tree technology, we used to do the syntactic analysis. That is, we first start from the sentence, then we will the noun form, then adverb form, and then finally at the root level, at the leaf level, we find the final parts of speech. That is, my is a preposition, dog is a noun, eating is a verb, and sausage is another noun. So all this way, we actually assign the parts of speech as well as we structure this tree. But this tree can be different from one to another. So one single sentence can have many tree as well. So that's a challenging part that you have to take care of while you do the syntactic analysis. There is a problem with ambiguous nature, that is ambiguity problem that I told you, that one sentence can have many parsing tree. So we have to understand we need to code the NLP model in such a way that the computer can actually end up in the correct or closely correct parsing tree, because there can be more than one correct parsing tree as well. For example, what books were written by the British women authors before 1800? So this sentence is very complicated. Just try to listen again. What books were written by the British women authors before 1800? So now this sentence has many questions behind it. So to understand these questions by a computer, for example, if you ask your Alexa that what books were written by British women authors before 1800, the Alexa needs to apply the smart NLP technology to first identify the books which were published before 1800, then which were published in Britain, and where the authors are only women. So they have to segregate all these things, and finally the subset of the results will be the final output, right? So this kind of complicated sentence are very important to deal with while we talk about the NLP while we are building the NLP model. Then the final part after the syntactic analysis is a semantic analysis, and it is the most important part of every kind of NLP analysis. For the basic NLP analysis, semantic analysis is understanding the meaning, that the how computer understand that what you are trying to say. Okay, we understand that syntax is correct. Now what if the syntax is correct, and what does it imply, what it try to say? So when we talk about the semantic analysis, we can do the semantic analysis in two levels, the lexical level and compositional level. The lexical level represents the meaning of the word. That is, for example, what is your name? The meaning of what? Meaning of is, meaning of your, meaning of name. A kind of word basis level. And compositional semantic is the meaning of the whole sentence or the whole sentence as a whole, the complete meaning. For example, the Maharani serves the vegetarian food. So we use the first order predicate calculus for the lexical level semantic analysis. That is, we first choose the verbs, that is serves. Who serves? Maharani. What serves? Vegetarian food. Same way, I only have $5 and I don't have a lot of time. So here we have two sentences, right? Two independent sentences. This can be end with a full stop, or this can be joined with a conjunction. So we take the conjunction and over here, and we take the first verb have and second verb not have. That is the don't have. So what we have, first who we have, the speaker, that is I, and what we have is the $5. And what I don't have, who I don't have, the I, and what I don't have, the lot of time. So use of first order predicate calculus is very important to understand each meaning of the sentence, to segregate the sentence on the basis of the verbs forms. Why this language understanding is important? Just for example, here this person is speaking to his dog whose name is Ginger, and he's instructed like, okay, Ginger, I have had it all. You stayed out of the garbage. Understand, Ginger, stay out of the garbage or else. And he's scolding his dog a lot, and his dog was so innocent. He just listened like blah, 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 Ginger, blah, 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 Ginger, blah, 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 blah. So to that dog, the Ginger is the only word which he understands. Because every time he listened to the word Ginger, he know, that is my name, and he go. And he don't understand all these things. So language understanding is a very important. So our goal is for deep understanding, which requires high understanding of the context, high understanding of the linguistic structures and linguistic semantics. But the reality is very important, because in the reality, the matching is not always very deep way. It requires very robustness and amazing NLP models for a better understanding. But till now, at least in 2022, we are standing right now, and we have quite good NLP models available in our market. And our Siri, Alexa, and Google Assistant, all these things are working quite well. So for the NLP analysis, I prefer Python programming language. To start with, you can use Python programming language because there are a huge number of libraries are already available in the Pythons. For the NLP packages and the NLTK packages, everything are available. It provides an extensive collection of tools and libraries to use a great number of NLP functions, and it has a good POS taggers and all these things. So you can use the NLP. I'm sorry, you can use a Python for the NLP. So let's now see some of the real-time also examples that which we can work with the NLP. So these are the very basic and the most important examples where we can build a chat box, information retrieval algorithms, information extraction algorithm, question answering algorithm, text summarization, and machine translation. This has a very well-defined problems, but also I will give you a huge collection of problems which even if you choose just one, you can finish your whole thesis. So we all know the chat box. Chat box are the very usable things which right now all the websites are using almost. Like they use the chat box in their. So chatbot can be two types. One is the AI built chat box, another is the MLDL based chat box. So AI based chat box is like just if else things, like which you have already feed some of the predefined answers. If you go to the question, if you do the question, they will answer the predefined response from its dictionary, and they will you will get the answer from the chat box. But email and DL based chat box are little difficult to build, but actually people are also using the chat box where you can get an experience of a real-time customer care executive or a customer representatives, where the chat box is usually talks like that of the example which we have listened to, that of the Google Assistant. So that's the MLDL based chat box. This is a basic rule-based chat box works, which I told you that the rule-based means like if-else based. That is the AI-based chat box. I think we have less time, so I'll just move forward. And the second example is the question answering, which is also very important aspect to build on the part that how we can actually understand the different aspects of a technology with the help of question answering system. Text summarization is a very important example or a very important application what we can work on different types of to understand the different types of big documents. For example, the text summarization technology can be applied to the legal documents, because to read a 300 or 500 page document is very important, very difficult. And if you just write a small Python code which can do a text summarization with the help of the preloaded NLP model, and if you apply that on a huge document or a huge story or a huge novel, then it will automatically, in a blink of second, it will automatically learn every part of the document, and it will return the summarized text to you, so that you can at least understand that what is behind that 500 page document. And these are all done by NLP. Machine translation, which we have already told that how we write in the real time and how we get the results in our foreign language in a real time. So here I write something in English, it supply me with the same thing in a Korean. So these are the another enterprise level examples of an NLP. You can take a short screen, quick screenshots, and you can take, if any of one of the research area you pick, you can actually finish your PhD thesis in this area. So these are really helpful research areas which are not much well explored till now in the area of NLP. So these are all open area right now. So how to learn NLP? So first you should have some prerequisite knowledge about probability and statistic and basic linear algebra and calculus knowledge, machine learning knowledge, and obviously programming, preferably in Python, but you can also work with R and other languages as well. It's up to you. So to learn the NLP, you can either read the book by the Daniel Jurowski, which is a very famous book on the speech and language processing. And you can also read my book on natural language processing. So I will show you my book over here now after this. Okay, just let me show you the book. Should contained. Just a minute, I'm just sharing. Yeah, so this is the book that I wrote last year for the not the last year in 2020 for the this book is not for sale. Actually, you cannot get this book on Flipkart, Amazon, or anywhere, because this book has been published by Government of Korea as the university level textbook for all the university in South Korea. This is the compulsory textbook for all the masters and PhD level students in South Korea. So I written this book, and the book is very much covered mostly all the topics in NLP. So as I told you, this is a Government of Korea book, so it is not for sale, not for any kind of reproduction. So if you need this book, you can, it's a 400-page complete book on NLP. If you need this book, then you can email me and I can personally share this book with you. So, I'll just share this last part of my thesis. Last part, yeah. So you can, so you can practice the NLP. There are hundreds of examples already in the GitHub, so you can just randomly go to the GitHub. You can take some random codes and copy paste them on Python and just practicing. While you do more and more practice, you can really really improve your NLP skills. So I finish now, and I'll talk about a little bit about my university. This is my university, Tongyang University. It is based in the southeast part of the South Korea. It's a very beautiful city of Busan with the edge of the Pacific Ocean and the mountains. And this is my university campus. And I have a small lab in my university called Chatterjee's Neuroimaging and AI Lab. Currently, I have 10 in-lab students and 2 external students, and all these 10 students contains like 4 PhD students working with me, and 2 RA and 3 masters, and all these things. And all these people are working mostly on the part of computational neuroscience, schizophrenia, and the NLP and sentiment analysis, time series analysis. Mostly all deals with like machine learning and deep learning kind of things. So my most research area is like computational neuroscience. So if you want to know more about me, you can go to my lab page, that's size.google.com, view Indira Chatterjee. You can visit my official homepage, or you can visit my university page as well. So this is my email ID, indranath.cs.u@gmail.com, and this is my web lab page. So if you want to learn more about me, if you want to learn my papers, my books, and if you want to get the PDF of my books, you can visit my lab page as well. So if you have any question, anything, you can email me anytime. So thank you for listening, and I hope that my throat is still now very much infected with COVID. So I had a very bad time continually talking for 1 hour, but I hope that I'm well audible to you because I cannot speak louder today. So thank you for considering.
Thank you very much, Dr. Nachatari, sir. It was a very nice and very interactive lecture. Now, I would like to request to our participants if they have any kind of query, the session is open for the question and answers. Participants,
sir.
do you have any kind of query?
Good afternoon, sir.
Good afternoon.
Sir, does the NLP, when we write NLP program, will it be easy in supervised learning, sir? Like if the agent is supervised comes under supervised learning, then NLP programming will be more easier, sir?
It depends on the application area. For example, if you're working with some data, which you have all kinds of ample amount of data and with a classified or the label data you have, then it's good that you use a supervised learning, because it's always acceptable that supervised learning has a very good efficiency.
Okay, sir. Thank you, sir.
Welcome.
Sir, I'm looking for the research paper, sir, because I wanted to do PhD in this. So any sources for getting the research papers, sir?
You can contact me, or you can go to my homepage. You can get my books and my research papers, all the PDFs over there, and you can also email me if you need any help. So my PhD students are also working on NLP, so I can help you in that.
Thank you, sir.
Any more queries? Participants, any queries, any doubt? House is open for question and answers. You can write in chat box also if you have mic issues. Yeah, he will share his slides. So please share your slides also with me so that I can share with the participants.
Okay, sure.
Any more queries?
Sir, is there any opportunity for the Indian faculties or students to do some kind of visit workshop, schooling, like summer programs at your university?
Yeah, there are a lot of opportunities for the exchange programs for the students as well as for the research scholars to visit the university as visiting scholars or visiting students. So you can just that thing is not under my delegation. So you can visit the international affairs page of the website of the university website. There will be see there are a lot of openings for the foreign students visit, or the as an exchange student or the exchange researchers.
Thank you, sir.
My pleasure.
More queries? Any more? Indeed, it was a great lecture, sir. I know there was a problem with your health. You are not feeling well. Still, you have given us your valuable time. It's a pleasure for us, sir. Okay, now I would like to call Dr. Abhishek. Dr. Abhishek, are you there? Abhishek, sir?
Yes, sir. So my voice is clear. Hello. Yes, my voice is clear.
Yeah. Please
Hello.
propose. Thanks.
Hello.
Yes. Your voice is clear.
Okay.
Your voice is clear.
Okay, fine, sir. Okay, thank you very much, sir. It is my honor and privilege to propose a vote of thanks. I, on behalf of Department of Computer Science, Indira Gandhi National Tribal University, Amarkantak, would like to thank Professor Indranath Chatterjee, sir, to deliver a lecture on natural language processing. Sir, in this talk, you discuss about the importance of communication and how it is important in various other streams like computational linguistics. You discuss the importance of NLP in various applications such as robotics, Grammarly, Alexa, email filtering, and machine translation. You discuss about how the NLP hardened with the various good examples. You also presented the importance of NLP with live video demonstration. You also explain various challenges in the LP which will be beneficial for new researchers. So really this lecture was very wonderful, and our participant has definitely gained a lot of knowledge from this lecture. Thank you very much, sir, for accepting our invitation and delivered a lecture even you suffered from the COVID. Thank you very much.
Thank you so much, Dr. Abhishek and Dr. Pawan. It's really my pleasure to be here, and it's a lovely audience, and all of the people over
Sir,
here, and we have very
I'm very
interesting.
thankful.
Yes, because it is not much common in other FDPs where the
Yeah,
participants
sure,
are so much
sir.
active in the late evening or the afternoon sessions. But I'm really happy that these participants are really very much active and asking questions. And I'm really happy because when you have a very interactive session, when you have active participants, the teacher or you both are professors, you all know that it gives us good feeling to give a speech. So thanks to you, and it's really congratulations for organizing a very good session for the students and research scholars.
Thank you very much, sir, for giving your valuable time and support to us. Thank you very much.
Thank
Have
you,
a
my
nice
pleasure.
day and nice health, sir. Take some rest. Thank you so much.
Thank you.
Good evening, sir.
Yeah.
Sir, that was a very informative and scintillating speech by Professor Brindarat Chatterjee. It was really good to have you as our speaker, and we were really inspired about the way in which the approach and the flow that you took it, to deliver the content to us. It was very nice to have you, sir. Thank you very much. It was well conducted indeed. Kudos to the
Thank you
organizers.
so much. Thank you so much.
Such a good
Thank you very much,
resource
sir.
person available for us.
Sure. For anything, you can contact me anytime.
Yeah, I'll mark a mail to you, sir. I'll be in touch. Thank you.
Sure.
Thank you, Chatterjee, sir.
Thank you,
Thank you
sir.
so much. Okay, participant, just fill the feedback form. Okay. Have a nice day. And now I'm stopping the meeting. Okay.
Okay, sir.
If you have any query, just ask to me.
Sir,
Any doubt? Yeah, Abhishek, sir.
Sir,
Any doubt?
Sir, can we have Professor Chatterjee's email ID, sir?
Yeah. I will send.
Well, thank you so much, sir.
Sir,
Thank you.
one sir.
Yes, sir.
One small query, sir. One small question. Like, are we trying to gather all the slides that is being used by the professors to be shared by with the audience, sir?
Yes. Okay, whatever they send, I just send in Telegram.
Sure, sir. Thanks for the effort.
Thank
Appreciated. Much appreciated, sir. Thanks.
you. Thank you so much. Thank you.
Welcome, sir.
Okay, Chatterjee sir has sent his email ID. Let me send in chat box also. Okay.
Yeah. Thank you, sir.
Okay, I will say I will share on Telegram link also. Okay. Thank you so much. Have a nice day. Please fill the feedback form and fill the attendance. Thank you.
Thank you, sir.
Thank you. Yesterday's
Thank you,
holiday,
sir.
who's asking? No, there is no holiday at all. Okay, Friday. Okay, we have 10 to 4, then 4 to 5. There will be the valedictory and feedback sessions. Okay, you can put your feedback over there. 4 to 5. Okay, there is a valedictory session. So I request you all will be there at a valedictory session also.
Tomorrow is the last session?
Tomorrow, 10 to 4. Yes, tomorrow will be the last day.
Okay, sir.
Okay, so we'll be there. Thank you.
Thank you, sir.
Thank you. Let me end the meeting. Okay, any doubt? Should I end the meeting? We will meet at 10 o'clock sharp in morning. Okay?
Okay, sir.
Hello.
Yeah.
Sir, could you send the attendance link of evening?
I have already sent multiple times, more than 10 times.
Okay.
You just check through the chat box, it will be there.
Okay. Thank you, sir.
Somebody asked about attendance link. Let me share the attendance link at last time. Dear participant, please left the meeting. Meeting is over. Please left the meeting.